Hello my dear champions, welcome back to our channel Kickstart Karnataka. In this class today, in this one short lecture today, we're gonna cover up a major chapter in the preparation of KCET, right? Why major? Two reasons are there. Very high weightage. Very recently your, I think 2 days back, your blueprint for boards is out, right? So you know, if you have gone through the blueprint, you will know this chapter, this year as well, is coming for 17 marks in second PUC board. In second PUC board, out of which you'll have 3 MCQs, 1 2 marker, 1 3 marker, 1 5 marker, as well as 1 4 marker questions. And for KCET, in the KCET exam, that is going to be in April, you'll have close to 5 questions from here. Means 5 marks in CET and 17 marks in your boards. Not only that, this is little bit easier than what we have in the highest weighted chapter, which is integration. So if you go to the integration side, you'll have again 18 marks plus 6 marks over here, plus 1 on both sides. 6 questions in integration comes, and 18 marks is the total marks weightage in as per the blueprint. But that is integration. Little bit of the higher difficulty level than what we have over here. So basically, this can be something that can be a very good friend of ours. So what we need to do? We need to befriend it. We need to become good friends with this concept, learn it properly. All the questions we have to solve, we need to put more efforts over here because it is very high rewarding in nature. Okay, so in this class, I'll cover up many questions, of course, but before I go and solve problems, we will learn each and every concept that is important for your syllabus. Okay, and alongside of that, we'll move on with our problems that can be on board MCQ side. NCERT subjective questions can also be there, and we have KCET MCQs. Alongside, I will solve some PYQs also. Some MCQs, which is non-PYQs questions, and some KCET PYQs also I will solve in this class. So I think it's very clear why we should watch this session, why you should learn from this session, right? Okay, now if you think whatever I've said over here relates to the problem, question, a problem statement basically means how can I work around this chapter. And if you think this will be helpful to you, or if you watch it and if you find it helpful to you, do not forget to hit the like button and subscribe to our channel for more upcoming sessions like this, right? Because I'm doing many things right now on our platform. You can find our live classes in the evenings. Okay, we have weekly 2 lives. Then we have one shot lectures coming twice, one for second PUC, one for first PUC. We have lot of math capsules, means small sessions that I discuss many complicated questions, complicated concepts in a simplified way. Simply what you have to do, check the playlist of all those in our channel Kickstart Karnataka. You'll find all of that available. Start learning from there. Okay, let's start then. Okay, so sir, let's start the chapter now. Already enough of time you have taken. I understand that your time is very important, but let's start. Okay, sure, let's start. The chapter starts from continuity. And it is important. This question directly comes for 4 marks in boards, as well as sometimes it comes for 1 mark in KCET. I mean, this concept over here is worth 5 marks. Since we know that as a KCET aspirant, both the scores are important. Let us understand continuity so that we will never forget about it. Okay, when I say understand, means any question that comes over here, we should know how to solve it. The concept is very simple. Fx is continuous at x equals to a if all 3 conditions are holding true at the same time. At the same time, what it means, f of a should be defined, means function value at the point a should be defined, it should exist. Okay sir, then limit of the function should also exist, and that 2L should be equal in nature, means limit of the function which is existing in nature should be equal to f of a, and should give you a finite value, If it is infinite, then what are we going to say? It does not exist. So it should be finite and equal. What should be equal? limit of the function at that point and function value at that point should be equal. In detailed way, what we write, the LHL should be equal to RHL should be equal to f of a. The LHL is written like approaching fx from x tends to a. Again, x tends to a but positive side, so x tends to a plus, okay, should be equal to f of a value. This is the definition of continuity at a point, okay, continuity at a point. What about discontinuity, sir? Then if any one of the condition is not fulfilled, that becomes the reason for discontinuity. If let's say limit does not exist, discontinuous. Limit exists but not equal to f of a, discontinuous. Limit exists, okay, so that's a condition, okay. Now when limit of this does not exist, means what does this represents? This represents LHL and this represents RHL, right? So LHL or RHL, either of them does not exist. Wherever you have that condition, you'll say limit, you'll say the function is not continuous or discontinuous. Both one-sided limit exist, means both of the LHL and RHL exist but are not equal in nature. This is not equal to each other, means yes, LHL value is let's say a and RHL value is b, but they are not equal. A is not equal to b. Then we'll say this is example of jump discontinuity which we cannot remove, also called as non-removable type of discontinuity. When the limit does not exist, we'll say that is condition of non-removable type of discontinuity. Next, this is the case when it is called as removable type of discontinuity. What's the meaning of that? Very simple. When limit exists, LHL equals to RHL means what? It means limit exists but not equal to f of a. We can simply define the function again and make it continuous. So that's why it is called as removable discontinuity. Again, don't worry about that. We don't ask you in the question solving. If you look at PYQs of boards or CET, you'll never find that. They're asking you to remove the discontinuity. They never ask that. Okay, this problem is not there, but just it is good to know that. Small concept, one term, good to remember. And x equals to a will be called as point of discontinuity. Same, if it is continuous means point of continuity. If it is discontinuous means point of discontinuity. Next concept is, and very important concept is, algebra of continuous function. This concept is useful for your board solving problems. Again, this is applicable almost everywhere, okay, applicable almost everywhere, but specifically on this definition they ask questions in boards. They've not asked many times, but they can ask. The conditions are, if function f and function g, the function f and function g are continuous at the point x equals to a. If at x equals to a, function f and function g are both continuous, then f plus g is going to be continuous, means some of the two functions will also be continuous at that point. Also, difference of the two functions will also be continuous at that point. That's called the difference rule. Even the product will be continuous, and you'll have the quotient also will be continuous provided the denominator is non-zero. So f by g will also be continuous provided the denominator g of a should be non-zero. Means algebra of continuity holds true for all the cases: sum, difference, product and quotient. Next, multiplying with a scalar constant k. If f is continuous, even kf will also be continuous at the point a. Scalar multiplier. Composite function has a different condition. Over here you have to be careful. So if I'm talking about FOG, means fog, then fog works like this. G should be continuous at point A. Here, G should be continuous at point A, and F should be continuous at the point GA. For F, the point is no longer just A, it is GA. Okay, because if you write fog, this basically means what? F of GA. So G should be continuous at point A and F should be continuous at the point GA. At the point GA. G at A, F at GA. This is called as condition for composite function. For fog to be continuous, if I write GOF, just opposite, F should be continuous at A and G should be continuous at F of A. Okay. So you can see how extensive, how beautifully this notes I have made for all of you. If you go through this, it will be very easy to follow up. Okay, and since I'm going to solve a different type of problem over here, all varieties, so it will be very, very useful for all of you. Okay, and to access all the notes, to know about all the classes, you have to follow only 2 steps. To know about any upcoming schedule of the class, which class is scheduled, on what date is coming, okay, did it come or not, is there a live class, is there a recorded session, what all is there. All this communication you will find in our WhatsApp channel. Any update comes from board, KCAB, KEA, any update that comes will be provided in the WhatsApp channel. The link for that you'll be finding in the description of this video. Please go and check it out. Join the WhatsApp channel. There's no charge for that. Just simply join it to get access to the all the updates or class schedules. Okay. Again, to download notes and many more, we have brought for all of you something called as all-in-one learning platform, and this is completely free. There's no charge for that. This is a next gen technology based very good learning platform provided by Vedantu, so that you all can, even YouTube student can be able to learn in a online classroom, okay, for no charge. No problem. Let me show you how it works. Simply click on any of the videos, for example this video's description. Okay, in the description you're going to find this title as join the free ACE KCET 2027 course now. Click on that, you will have this page open in front of you. This page open in front of you. Just to be sure, take the title, Prime Course ACE KCET 2027. Okay, sir. And this is going to be the image on the page. Once you come, click on buy now. Sir, there's a charge. Actually, no. If you click on buy now, okay, since I have already logged in, it will ask you to create a login credential, means login information. Put your number which is active and put an OTP. Once you have done that, you can log in again on the same platform, same website, and once you log in, you will find this as your course. Can you see this? YouTube course. So all the lectures of YouTube is available over here. Okay, you get to have the schedules. You can ask your our own AI agent Ved. Any doubt you have, you can ask Ved for doubt solving. Schedules are available over here. Notices, performance, all this will be there. Okay, and if you, let's say I want to show you, then you can also attempt test. We are working on it. Very soon you will have that access also. Click on this. Let's say I want to see the classes. So these are all the classes. If I want to watch it, let's say I want to watch this session again, or let's go to the latest class. Okay, yes, okay, yeah, let's say I want to study KCET first PUC. Achha, this is for first PUC students also. If you know anybody who is learning for first PUC, so let's say I want to refer to this class. Okay, you can watch it from here as well as if you want to note the notes, click on the smart notes. Okay, sorry, this is not uploaded. Okay, I'll check it out. Okay, I will check it out. Let's say if this is here, yeah, so you'll see all the notes are over here. It's all uploaded. I will work on that one which was missing. Okay, so basically all the class notes, question solving, everything is available over here for your benefit, and again free of cost, no charge. Just that your efforts are the charges. What is the cost of this particular AIO page, all-in-one learning platform? Your efforts, your honesty to study is what we need over here. Okay guys, so let's continue. Okay, let's continue. So all this is available for you. Please start using it in the best way possible. Spend some time it, understand the platform, how it is, get used to the use of platform, how to access everything, and start learning. Okay, All right, so next what we have, sir, continuity in an interval. This is very important, very important. They simply ask questions on it and you have to identify the interval and check on it. Okay, so for open interval there is no problem. F is continuous in AB. This is very simple. So if you write the interval AB, open interval AB, it means this is A, sir, this is A, and this is B. This is B. So all the points which is coming in between A and B, all these points, at all these points, function should be continuous. In the open interval AB, at all the points between the point A and B, the function should be continuous. Then only we can call the function continuous in the open interval A, comma B. What about closed interval, sir? In closed interval, we have three conditions. That it should be continuous in the open interval. If you're looking for closed interval, we have three conditions. Number one is continuous on the open interval A and B. At the point A, you should have right continuous. You should have right continuous. What's the meaning of that? What is the meaning of that? It means since the left hand side part of the A is not in domain, if the interval is A to B, right, then this part is out of the domain, out of this side is out of domain. Right continuous means that f of A should be equal to RHL, and for B, what it means? Left continuous. It means f of B should be equal to LHL at the point B. Okay, so at the point A you should have right continuous, at B you should have left continuous if the interval is A to B closed. So three conditions are there. Continuous in open interval AB, at point A right continuous, at point B left continuous. That is for continuity in the interval, closed interval AB. Okay, when can we call this is discontinuous on an interval? Even if it is continuous at one point. This is very extensively used. If it is discontinuous at even one point, we call it to be discontinuous in the entire interval. Discontinuous everywhere if it is discontinuous. Okay, continuous everywhere if it is continuous on the entire number line, all real numbers. Let us look at continuity of some functions. Constant function, continuous everywhere. How come, sir? The graph of this. Look at the graph of this. This is my y-axis and x-axis. I can draw better. Let me draw it better. Okay. If this is my y-axis and x-axis, this is the continuous function, right? Y equal to c. So continuous everywhere on the entire number line. Rational function everywhere except for where it is 0. So let's say this is my rational function I'm taking, y equal to x, y equal to 1 by x. This is the graph. So continuous everywhere except for where it is 0. Right? The denominator, when it becomes 0, you have to remove that. Modulus function graph, roughly I'm drawing again. This is the graph of modulus function, again continuous everywhere for the entire real numbers. X power n. Actually, this is x power minus n. This is x power minus n. Again, this will be same as this. Will act as the same rational function. Okay. Sin x, cos x, e power x. For all these three functions, what is it? Continuous everywhere. The graphs. Okay, you've all seen that. Sin x, cos x, e power x graph. Tan x everywhere except for odd multiple of pi by 2. Same for secant also. Because, who will tell why? Because tan and secant at odd multiple is what? So tan is undefined, cos is 0, so secant will be also undefined. Right? So this is what? 2n plus 1 represents odd multiple of pi by 2. Correct, right? So if you look at this, from all real number, remove the odd multiples of pi by 2, then it will be continuous in the entire real number. except for those odd multiples of pi by 2. Okay sir, cot x and cosec x, again integral multiple of pi. From the all real number, remove the integral multiple. For example, 0, pi, 2 pi, minus 2 pi, minus 3 pi. Remove all those integral multiples, right? If you remove that, it will be the interval where it is continuous. Cot x, cosec x is continuous on this interval. Log x, graph, you remember? This is the graph of log x, either this or the decreasing wala part. Both of them continuous, the interval 0 to infinity. Only positive side is there. Sin inverse of cos inverse of x in the critical domain -1 to 1. Okay. Tan inverse, cot inverse everywhere in the real number. Graph, you have to remember that because tan inverse graph is what? This, right? The graph of tan inverse, and cot inverse graph is this. This is tan inverse. Guys, I have drawn all these graphs for you, okay, in the ITF one shot. Please go and check it out. Sec inverse, cosec inverse, again, except for -1 and 1, it will be continuous everywhere. Clear? Clear? So basically, all these are what? Domain of these functions. So in one point, we can say that all the standard functions are continuous in its domain. So if you look at all of this, this represents domain of these functions. Okay, so all these functions are continuous in its domain. Okay, in its respective domain. Okay. All right. Let's look at an example of sin x plus cos x. Very popular question. Sin x plus cos x. Sin x, we know, continuous everywhere, we just saw. Cos x also continuous everywhere, we saw. Right? So sin x plus cos x will also be continuous everywhere. Sin x is continuous for all real numbers. Cos is also for, say, all real number. Sin plus cos will be also continuous for all real number, and difference will also be continuous for all real number. From where? Algebra of continuity. This both concept is coming from where? Algebra of continuous function. Makes sense, guys? Okay. Yes, it's a question. Don't worry, we have questions. Wait. Differentiability. Look at this. So differentiability is defined using first principle. Okay, this is the first principle. What it says? F of x minus f of c upon x minus c when limit x tends to c. This value should exist. This limit value. This limit value should exist finitely. It means the limit should be there and the limit value should be always a finite value. When that happens, then we can call the given function to be differentiable. Now think about it. When can we call this given limit existing in nature? When the left hand limit part, when it approaches like this, when the limit x tends to c minus, okay, of course the function should be equal to limit x tends to c plus this. So this side is called as, in this case, left hand derivative, and this is called as right hand derivative. So basically this limit exists when left hand derivative and right hand derivative is equal. So differentiability is true, or a given function is differentiable if the left hand derivative is equal to the right hand derivative. When the left hand derivative is equal to the right hand derivative, then we can call the given function to be differentiable in nature. Again, how do we write left hand limit? That we will see right now. Not a problem. So notations that we use very generally is f dash of c. This we rarely use, but is still there, and df by dx also we use at times. F is a differentiable function if it is differentiable at every point in its domain. I can call a function differentiable if for the function's domain it is differentiable everywhere. Okay, means at every point in real numbers. If I'm talking about everywhere differentiable. Okay. Acha, one more thing. Derivative means what? Derivative means this derivative you see everywhere. derivative is actually what? Acha, I can do better. 1 second. 1 second, guys. Let's look at this. This is important, okay? So derivative actually means slope or the tangent value at that point. Means at that point. It should always be at the point. So if you guys remember this curve, let's say, and people used to ask you for this line, find the slope. Find the slope. Correct, right? You should take this as point x1, this as point x2, this right here as the point y1, this is the point y2, and in coordinate you used to find slope as delta y upon delta x, and this was what? y2 minus y1 upon x2 minus x1. This was called as an average slope, basically, for this, basically given the chord. Sorry, let's forget about average, because average concept will come if I'm taking this as dt graph. If I write this as distance time graph, then it will become what? Or sorry, displacement time graph, then this will become average velocity, right? If I write this as displacement time graph, then this becomes what? Average velocity. All of you will agree. Grade 10 physics. But what happens if this x2 moves right here at the point x1? Means they are very at the same point. Then the graph will change. Then the graph, here we had chord, okay, but in that case we will have a tangent. I can draw better. Let's say draw a tangent, and then I'll draw the curve, and then you'll have a curve like this. So this is a tangent. So in the case of average velocity, you get a chord, because for any arc, this line is what? This is a chord, right? So you find slope of the chord. But in the case of this case, this is called as case when this value, can you see this? This delta x becomes or goes to almost 0. What it means? It means when x2 and x1 are the same point, when this is at the same point, see, x2 is at the point x1, they are at the same point. When x2 and x1 are at the same point, then delta x becomes what? 0. Sir, what are you saying? Look at it. If let's say this is 5 and this is 2, difference is what? 3. If this is 3 and this is 3.000000001, if this is 3 and this is what? 3.000000001, difference of x2 minus x1 is what? 0.000000001. Very small value. I am saying that only. When x2 goes to x1, then delta x means difference in the x goes to 0. It is not 0, but very close to 0. So basically this you see, delta y upon delta x, when this limiting value, what? Delta x becomes or goes to 0, this is what you get as dy by dx. When delta y by delta x, what is this slope? This slope of the chord was there. But if you approach this delta x to 0, means when you make the when you make the point x2 to close to x1, then what will happen? Then this will behave as a tangent, and this represents what? Slope of a tangent. Right? This represents slope of a tangent. That's why derivative represents slope of the tangent. In many questions you will find we also use concept of tan theta directly, because tangent slope is what? Slope formula is what? Sometimes we will use it. So remember this. Sometimes we use slope as tan theta So in derivative also we use that concept at times, question to question. So this is clear what is the meaning of, geometrical meaning of derivative. Okay? Yes. It represents the slope of the tangent at the point, whichever it is given. Derivative at that point means that only. Okay? Again, that was the how, what is the meaning of differentiation? This is again, when will it exist? So I said that the limit that I wrote, that was called as derivative from the first principle, should exist in nature. That limit to exist means the left hand value should be equal to right hand value. This is the left hand value, left hand derivative, right hand derivative. How do you write it? So of course I wrote this as limit limit x tends to, let's say, c, and right hand means we'll put plus, what was it, fx minus fc and x minus c. So when I take x tends to c plus, I'll basically replace x as c plus h. So if x goes to c, if x is c over here, then what will happen? Check this out. If I take x as c, h will go to what? 0. If this is c, means h will become 0. C equal to c plus 0. So this will transform. Check. Limit h tends to 0. This has become this now. In place of x, we'll write c plus h. So c plus h minus f of c upon x will become again same thing, x plus h, c plus h minus c. This is from here. This cancels. So I can rewrite this as simply h. This is the expression for my right hand derivative. Same way let's write for left hand derivative also. So we'll have over here limit x tends to c minus, this is as it is, this is the limit value. Over here we're gonna do what? Replace it by, we'll replace over here by x by c minus h. Again they'll have, if x goes to c, h will go to 0. Put here c, cancel, h will go to 0. Check. The limit will become what? Limit h tends to 0, f of c minus h minus f of c upon x is c minus h, right here c minus h minus c, c and c cancels. You're left with what? Minus h. Left with minus h. This is the expression for your left hand derivative and right hand derivative, very useful in the board's question. Whenever differentiability is involved in board's problem, let's say 4-marker or 3-marker questions, then you have to utilize the steps according to these limit values. For boards, for CET they have different methods to do it faster. Okay, but this is clear, right? So what is the condition? Right hand derivative should be equal to left hand derivative and both should be a finite value. It should not go to infinity. Both should be a finite value. Continuity versus differentiability, the relation between both of this nature of function. So if a given function, the most important ones are over here. So let me highlight it for you. 1 second. So the most important one is this. Differentiable, then always continuous. And if it is this also. This also, excuse me. Yeah, this right here. This you have to remember, this is very, very important. So if you have a differentiable function, if f is differentiable, it will always be continuous. Don't even worry about it. And if it is discontinuous, it will always be non-differentiable. Remember the two always condition, because the other two is may and may not be. Why I am asking you to remember the two always condition? Because if a question is based upon always condition and you don't remember it, you will waste time solving it. Yes or no? If you remember it, then you don't have to solve at all. Listen to me again. If it is differentiable, always continuous. If you remember this condition, you don't have to solve the problem given on this condition. Same here. Discontinuous, always non-differentiable. Correct for all the cases. So don't have to check, don't have to solve it. These are may or may not be wala case. So even if it is continuous, we don't know. Not differentiable, we don't know. So this we have to check anyway. This we have to solve and check. But rule 1 and rule 4 is always true. So please remember the first and fourth. Second and third you have to check, right? Okay. Done. Done. So before I move on, continuity, if I have to understand with the help of graphs. Graph means, okay, let's take an example. So let's understand using graphs. Using graphs. What's the meaning of continuity and differentiability both? Continuity using graphs. How do you solve it, sir? This is simple. So whenever you find functions like y equals to ax plus b, ax basically going from 0, no? So ax, this is the linear function, always continuous. If you look at polynomial function which is parabola or cubic function, so all the example of continuous function. When can I have example of discontinuous function, sir? You can have, if you have, let's say, function like this, and there's open over here, this closed over here, then goes like this. Means there's a jump in the function. Means let's say this point at 1, on the left hand side the value is, let's say, 2, but over here the value is what? 4. So if you go to 1 from left, okay, the answer is 2. But if you go to 1 from right hand side, what is the answer? 4. So clearly your left hand limit is 2 and right hand limit is value is 4. Are they equal? No. It means not continuous. This is the case of discontinuous. This is not a standard function. I'm just giving you example of it. Okay. What about non-differentiable? Now this is very, very important. Sorry. Differentiability. Differentiability. Examples to check for which is differentiable right now in the beginning. So you can check, let's say this function, sin x. This is what? Sin x between minus pi by 2 to pi by 2. What is this? Minus pi by 2 to pi by 2. Smooth curve. More examples. Parabola. Cubic function, log function, exponential function. This is e power x, this is x cube, this is what? This is log x, this is what? X square. All these cases. All these cases. Differentiable. Whenever you find, very important, sharp corner or that type of function or break. So thing is, if you have sharp corner or break, this is the case of non-differentiable function. Non-differentiable function. So if you ever find this particular case over here, if you have sharp corner or break in the given graph, you will have the example of non-differentiable function. Is this clear or not? Because in many questions of MCQ style, the job becomes much easier if you know these two understanding of graph application. Okay, moving on. solved, prove f of x equals to mod of x minus 1 non-differentiable at point 1. At point 1. How do you solve it, sir? Simple. So if you look at the branching, if I want to show you this again, critical point is given as 1, means when x is more than 1 or x is less than 1. When x is more than 1, take a value 2, 3, 5. 2 minus 1, 1. 3 minus 1, 2. 5 minus 1, 4. All these are positive in nature. If it is positive, means it will open like this only. Positive, right? So nothing will be changed. Mod of 2 is 2. Nothing is changed. 2 is positive. What about mod of minus 2? What about mod of minus 2? That becomes minus of minus 2. That's how it get as 2. Mod of minus 2 is what? Minus of minus 2. Because mod of 2 minus 2 is answer is what? 2. Mod of minus 2 answer is 2. But how does it get 2? Because you apply negative sign to it. Correct? Now you check over here. For all x less than 1. Take example. Random number you can take. 0 you take. Take 0. Take minus 1. Put here. 0 minus 1. That's minus 1. Put minus 1 now. Minus 1 minus 1. Minus 2. And for all these numbers, the modulus will open with a minus sign. So clearly this will be what? Minus x minus 1, and this becomes what? Minus x plus 1. Right? Or I can write this as 1 minus x. I can write this as 1 minus x. Okay? Clear, right? This is 1 minus x. This value is 1 minus x. So, two different branching is clear. X minus 1, 1 minus x. Limit condition is same. Replace over here x as 1 plus h. Okay, for right hand limit, check here. You'll have 1 plus h minus 1, because this is 1 plus h minus 1. This is going to be h only, so we get 1 and 1 cancelled. We have only h left, so we have h by h, that is 1. Answer is 1. Same way, for the left hand derivative, you'll have what? To replace 1 minus h in this case. So right here, 1 minus h minus f of 1. F of 1 is to 0 only. Check here, 1 minus, I'm using no, 1 minus 1 minus h. Check here, 1 minus 1 minus h. Expand, 1 and 1 will cancel, you'll have plus h by minus h. What is the answer? Minus 1. Are they equal? Not equal, sir. They are not equal in nature. They are not equal in nature. So your right hand derivative is 1, left hand derivative is minus 1. Are they equal? Not equal. Hence it is not differentiable. This is you have to do if it is coming for board's subjective question. If the same question comes in graphical method, what is the question given us? Y equal to mod of x minus 1 at the point x equals to 1. Draw the graph. Look at the graph. This is the graph. After 1, what is the slope? Acute angle. Before 1, what is the slope? Obtuse angle. Acute angle means tan of, let's say this is alpha. So this is angle what? This is angle alpha. Tan alpha will be positive. Over here check, this is let's say angle beta. You'll have tan beta over here. Negative. Obtuse means second quadrant. More than 90. Obtuse means more than 90. Second quadrant. Tan in second quadrant is what? Negative. Acute means first quadrant. Tan is positive over there. Check. So this is your, this part represents your right hand derivative. This means tan alpha. This means plus. Over here we have left hand derivative, which is minus, which is, check here carefully. Clearly, a negative value can never be equal to positive value. Non-differentiable. This is the understanding, complete understanding. But we don't need that as well. Once you have drawn this figure, you can see over here, there's a sharp corner. at the sharp corner, which is what, x equals to 1, the given function fx is non-differentiable. Clear? Algebraic method is clear, graphical method is clear, the logic is clear. Does it make sense, guys? Have a look. Right? Surely. The part 3 is differentiation rules. Rules means product rule, quotient rule, chain rule, okay, and formulas for different functions. The formulas. Starting with the formula. Derivative of a polynomial function is what? N times of, if it is x power n, it becomes n times of x power n minus 1. Exponential function remains same when you have base as e. If it is any other base a, you'll have log a also multiplied to it. If this a constant is differentiated, answer is always 0, and log x derivative is 1 by x when the base is e. Log x, if you see, it means base is written as e. When the base is e, derivative is 1 by x. When base is not e, some other number, let's say a, what does this mean? It means log of x with the base a. Differentiate this, answer will be 1 by x log a. 1 by x log a. Sine is cos, cos is minus sine, tan is secant square, cot is minus cosecant square, secant is secant tan, and cosecant is minus cosecant and cot. This is for trigonometric function. The upper part was for polynomial, exponential and logarithmic. Trigonometric function part, the last over here is for inverse trigonometric. Sine inverse is 1 upon root of 1 minus x square. For cos inverse, same thing with the minus sign. Tan inverse 1 upon 1 plus x square. Cot inverse is same thing with the minus sign. Sec inverse 1 upon x times of x square minus 1. Cosec inverse is same thing with the minus sign. Got it? Clear? Formula should be in your mind. This is very basic, okay? If you are forgetting formulas, means, of course, nobody can help you. Nobody can help you if you forget formulas, right? Formulas is a must. We have to remember it. There's much more than formulas that we should know. But formula you should start with, and you should know the formulas, right? Okay. Product rule. If two or more, even more, yes. If two or more function is given in product, f into g, f into g into h, f into g into h into k, any number of functions given, usually they will give maximum till 3 functions, okay, they will not give you 4 or 5, anything like that. If it is given, you differentiate it like that, keeping one function as it is, differentiate the other one, g dash. Next, keep g as it is, differentiate f, so f dash. Product rule may, you differentiate one function at a time and other you keep as it is. And there is no preference order, no priority order. Here, very important, no priority. Here it is, no priority. No priority in the product rule. Quotient rule, priority to numerator. They give priority to numerator, means when you differentiate it, I'll write it over here as well. If you have f by g, you need to differentiate this, right? Take this as symbol. You differentiate f first, keeping g as it is, there's a minus sign, and then f as it is, differentiate g now divided by g square. You cannot differentiate g first. Here numerator is f, here numerator is f, you have to differentiate f only first. So priority in the derivative in numerator given to f. This is always g square. Chain rule, this works same way. So let's say you are differentiating a function which is given in terms of another function. Example, let's say I have to differentiate, I have a function y equal to sine t square. Sine t square. I want to find derivative of dy by dx. My answer will become what? dy by dt into dt by dx into dt by dx. Okay, differentiate sign, you'll have cos t square. Now differentiate t square, you'll have 2t dt by dx. What is my answer going to be? My answer will be 2t cos square t dt by dx. So differentiate sine first, you get cos t square, and differentiate t square, you get 2t dt by dx. So this is the chain rule. This is the chain rule. Example on that. If I ask you how many functions are there, think in your mind, just try to think right now. How many functions are there given in this? Means we have to differentiate how many different type of functions. Answer, is it 3? If 3, then it is right. First differentiate secant, that's the first one. This is second one, and this is third one. I have a request from all of you, please remember this. This is very, very useful and very highly used. Derivative of root x is 1 by 2 root x. Please remember this. Derivative of root x is always 1 by 2 root x. Now differentiate this. Y equal to secant tan root of x. Y equal to secant tan root of x. We'll differentiate secant. Let's say I'm going to take, okay, I've taken this as u already. So if I do that, it will become secant of u. So I'll differentiate this part first, then I'll differentiate u, and then I'll differentiate root x. Okay, check. So secant derivative is what? Secant u tan u. Derivative of tan is what? Achha, this is a mistake. Sorry. Derivative. Oh no, this is correct only. Yeah, that's correct only. Sorry. This is correct only. Derivative of tan u means tan root x. With root x will be what? Secant root x. And derivative of root x with will be what? 1 by 2 root x. So answer becomes combination of all. See, secant u tan u. This is secant square root x and 1 by 2 root x. Okay, so answer will be what? Here like this, 1 by 2 root x secant tan root x into tan root x, and we have one more into secant square root x into secant square root x. Please check. A very good question on the chain rule side. Next is implicit differentiation. So usually when we look at a function given to us in the question, they give in this form: y equal to f of x, y equal to f of x. This is the case of explicit function. Explicit function. But what if in the question they have not given y clearly as a subject? They have made an equation out of it like this: sin square y cos of xy equal to pi. It's an equation form given. We don't have a clear y as subject. Then how do we solve it? What we need to find out? We need to find dy by dx. Derivative value is what? Derivative of y with x is what? So what do we do in this case? We differentiate this as equation itself, and whenever you find a function of y, let's say if I have f of y, any function, it can be trigonometric, logarithmic, polynomial, whatever it is. If you find f of y, your derivative will be f dash of y, and always multiply with dy by dx. Be it any function, sin y is there, log y is there, e power y is there. Differentiate sin y. What is the answer? Cos y. E power y, e power y. Log y, 1 by y. Alongside derivative of the function, multiply with dy by dx also. Always. Have a look over here. differentiate it, you will have 2 sine y. Derivative of 2 sine square is what? 2 sine y. Derivative of sine y is what? Cos y. I'm going over here with chain rule. First function is the polynomial function, right? Square. So 2 sine y. Sine y is cos y. Is it over? No, sir. We have to multiply with dy by dx also. Plus. Cos becomes what? Minus sine xy. Is it over? Differentiate xy as well. So for x you will have 1 times of y, because if you differentiate x you will get x as 1, y is as it is, plus x as it is, differentiate this, you will have dy by dx, and this is 0. How come, sir? Differentiate x, you have 1, y as it is, plus I am applying product rule over here. Differentiate x as it is, differentiate y, dy by dx. Expand now. Check this out. 2 sine y cos y is sine 2y dy by dx minus over here sine xy, and in this if you expand it over here, y with this minus y sine xy, and again if you expand minus x sine xy dy by dx. Dy by dx. You're looking to find out value of dy by dx. So we'll take dy by dx common from the common terms, and rest all will solve like a linear equation. Okay, linear equation. So we have over here and over here. Take dy by dx common, guys. If you do that, you will have over here sine 2y minus x sine xy. This is x, okay? This is x. And this value, if you move on this side, you'll get this as plus y sine xy. Plus y sine xy. So my final answer, what will happen? This particular value, just write it over here as denominator. So y sine xy upon sine 2y minus x sine xy. That's my final answer. Clear? Is this clear? This is the case of questions where it comes for implicit function. Question of implicit function. I hope it makes sense. Parametric and second order derivative. Parametric function and second order derivative. Okay, have a look. In the parametric form, you will find x written in terms of f of t, y also in terms of another function g of t. X in terms of f of t, y another function. So we have a t over here. What we have? T is the parameter. T is the parameter. So how do we solve it? They're asking us to find dy by dx. So we find dy by dt, differentiate the function. So basically, dy by dx is given by f dash of t upon g dash of t. What is this? Dy by dt upon dx by dt. Okay, that's my parametric form. Sometimes they can also ask question which is on one function derivative with another function. Differentiate function f with g. So you're going to do what? F dash of x upon g dash of x, the way I've done over here. Okay, this is the concept of second order derivative. So far it is clear, right? Parametric form and derivative of a function with another function is clear, right? Okay, guys, if you have any doubt, please ask me in the comment section, or you can ask with Ved also. Okay, your AIO platform is there now, all-in-one platform. Simply enroll into that. Okay, it's for free. All right, it's for free, and once you enroll over there, you will have Ved. You can ask doubt to Ved as well. Okay, let me show you one more time. Okay, 1 second. Give me 1 second. Here it is. This is Ved, right? So if I, let's say, if I want to ask some doubts over here, I'll go to my home, let's say. Okay, you can see, you can ask your doubts over here in InstaSolve. You can ask your doubts in InstaSolve over here. Ved is there. You can ask your doubts here as well, and of course all the notes and everything is available for you to access, no problem. Okay, all that is available to you anyway. Notes and everything is available in the AIO platform. How to log in? Simply check any of the lectures. In the lecture you will find join free ACE KCET 2027 course now. Click on that link and enroll yourself for free. Start learning. All right, this is clear. Okay, let's move on then. Let's move on to the lecture now. So how to you ask your doubts? Clear, right? To wait in the AIO platform. Great. So that is for parametric and function derivative with another function. The last is second order derivative. This question will come for sure for 5 marks in the second PUC board. Differentiating another function with respect to, means differentiating the derivative with respect to other, basically you're going to differentiate the derivative. Sorry. So you'll have a derivative. This is called as first derivative. When you differentiate, that also is called as second derivative. What happens when you differentiate second derivative? Again, the third derivative and so on. This concept is from where? Successive differentiation. Successive differentiation. You keep differentiating it once, twice, thrice, like that. But in our syllabus, we have only till second derivative. We have only till second derivative. So usually what we do, we get the first derivative right, like this, f dash of x. We differentiate again, that will be your f double dash of x. F double dash of x. The way to write this is f double dash y2, or y double dash so on, or something which is very mostly common, d square y upon dx square. Or this is the second derivative, by the way. Second derivative. How you write first derivative? They're both important, okay? That's f dash y1 y dash or dy by dx, because in the question that comes for 5 marks over here, they'll be having equation form, and you can use either of the form over there depending upon what is given in the question. Okay, yeah. So again, I've given you the notations over here as well. Clear? So theory part is complete. Time to solve some. One more thing. One more concept is remaining, that is the logarithmic differentiation. This comes for 3 marks. This comes for 3 marks. Okay. Basically, you'll find question of the form f power g means exponential form, or f into g means product form, or f by g. Whenever you find these 3 forms in the question given to you, it means the question will be solved using the logarithmic differentiation condition. What is that? Simply take natural log on both sides and then differentiate as a equation. What if we have, sir, y? So basically, this was a function given to us, no? Y equal to f power g. Take log. It will become log y equals to g. So this will be what? Y log y equal to log of f power g. G will come in front as coefficient. The power rule is there. So gx log fx. What is the next case? Differentiate 1 by y dy by dx. Differentiate g now. You'll have g dash log f as it is, plus this time keep g as it is, differentiate log. So you'll have 1 by f, differentiate f from chain rule, you're going to get f dash. So your final answer comes over here. This y will be moved on this side. So your dy by dx actually becomes, since this y will go over there, y times of g dash log f plus g f dash by f, or we can write this y as simply f power g from here. Clear? That's my answer. This right here is my answer, guys. 1 second. Yeah. Okay. Clear? This is the formula we use for f power g form. Again, we can use it for, this is the condition that we use for log. Okay, log of x is f dash by f. Same thing is given, nothing else. We can use for this also. This is very common PYQ. When you have in product, let's say 3 functions are there, f times of g times of h, f into g into h. So if you apply the condition, it will become log f plus log g plus log h. This is in product, right? Log of f into g plus h. If it is given as y equal to f into g into h, take log. So log y equal to log fgh. It becomes what? Log y equals to log of f plus log of g plus log of h. Now differentiate it. You will have f dash by f, g dash by g, h dash by h, and y will be again multiplied over here. This is the condition, and it is used in these three cases: f by g, f into g, and f power g. This is an example of logarithmic differentiation. Logarithmic differentiation. Time to solve questions. Okay, on board style MCQs. I've taken 15 questions on that. Let us solve that now. MCQ number 1, board style. Okay, fx is mod of x, then x equal to 0. The function is continuous but not differentiable. Right, look at the graph. Mod of x is this. You can see the presence of sharp corner. At the point x equals to 0, which means what? It's going to be non-differentiable. Continuous because there is no break in the function. Is there a break in the function? Graph you check, there's no break. There's no jump as such. So this is simple as a continuous but non-differentiable function. Alright, next. Question number 2. X square sine 1 by x. Beautiful. They're saying f of 0 is 0, then find the... Okay, which condition is true? Alright, so before we understand the conditions given in the 4 options, let us break it down the value of sine 1 by x. What is the meaning of sine 1 by x? Okay, if I draw the graph of function sine x, this is how it looks. Keeps going both sides, right? So whether to negative infinity or to positive infinity, on both the sides, the sine function is giving me a finite value between -1 to 1. Means it will not, the sine value, the value of the sine x or anything inside sine, let's say sine theta, it will not exceed the interval -1 to 1. It will always be in the interval -1 to 1. This part is clear and it makes sense also, right? Because range is given -1 to 1 for sine theta. Good. So if I take 1 by x, when x goes to 0, okay, let's do one bit further. Let's say 0 minus or 0 plus. Okay, then 1 by x will go to what? Minus infinity. How come, sir? X goes to 0 minus means it goes to 0 from left hand side, means very small, very small negative number, means minus 0.00000001, very small negative number. If you do that in division 1 by x, that will become a very big negative number, right? So minus 1 by x, 1 by x will become minus infinity. Good. Same way over here, 1 by x will be plus infinity, and you can see sine 1 by x will be a finite value, here as well, same thing. How come, sir? Because if you put any value over here, let's say this is my infinity point, then sine will still be between -1 and 1, that is a finite number. Here also same thing, finite number. Means whether you have 1 by x going to negative infinity or positive infinity, sine 1 by x is in both the cases finite. This is clear. So this is basically acting as a finite constant, finite number. I can take, let's say, as a constant k. So this is a finite value. So since we have multiplied that with x square, means if you put 0 over there, the limit will be what? Simply 0. So it is continuous for sure, because if I find beta, limit of the function fx when x tends to 0 will be what? 0 square times of some value k. What is the answer? 0. And this is also equals to, please check, f of 0. So the limit of the function when x tends to 0 is equal to f of 0. Hence the given function is what? Continuous. Given function is continuous. What about differentiability? So for differentiability, we'll have to write the first principle. Limit x tends to 0, f of x minus f of, in this case, 0 only. Okay, I can write it better. I'll write directly, okay. I'll write directly in terms of h. So h tends to 0, and I write over here f of 0 plus h minus f of 0 upon h, okay, upon h. Please check. If you apply over here, you'll have f of h. F of h will be what? H square sine of 1 by h minus 0 upon, because f of 0 is given as 0, h, right? Limit h tends to 0. Check carefully, this will cancel this. You're gonna end up with limit h tends to 0, and we have h sine 1 by h. As I mentioned, this value is what? Again, finite only. This is a finite value. This over here is a finite value, means if you put 0 over here, this will become 0 into something, will be again 0 itself. Okay, so basically limit also exists in this case. And what limit is this? This is the limit for, you can call this is actually RHD. So if you go for LHD also, you'll have the same answer. You'll have the same answer. Try it out. You'll have minus h over here. This will become again h square, cancel, answer will be same. If answer is same, it means your LHD also will be equal to RHD, and they will both be equal to what? 0. In that case, the given function is continuous as well as differentiable. Got it? Sir, will I be able to do all this in the exam? I'll give you a hint. Don't do this part. This all you don't do. Please don't prove differentiability. Don't prove continuity. Because understand this. Please remember the expression x square sine 1 by x is always continuous at 0. Remember this. It'll be of lot of help. Okay? X square sine 1 by x at 0 is always continuous. Okay? Look for differentiability. Again, this approach will be faster. Moving on to question number 3. You want to look one more time? Question number 3. Y equal to log tan x by 2, then differentiate. How do you differentiate this? Combination of chain rule. So we'll write dy by dx, right, and differentiate using chain rule. Check. We'll differentiate this log first. So I'm gonna have tan x by 2 in the denominator. This will be in denominator. Next is what? Differentiate tan. I'll have secant square x by 2. Derivative of tan x by 2 is secant square x by 2. Is it over? No, sir. We still have to differentiate x by 2, and that will be 1 by 2. Write everything in terms of sine and cos. How come, sir? Because you can see I need to simplify in terms of double angle, which is x, and basically sine cosec. Okay, we'll check. So I'll write over here. I'll write this 2 in front. This 2 is there. No, I'll write in front because this is present in denominator only. Now over here sine will be, I can write tan as sine x by 2 upon cos x by 2. Sec square will come down and we'll have here cos square x by 2. This cancels. You'll have the answer as 1 by 2 sine x by 2 into cos x by 2, and the answer is 1 by, this is the formula, sine two times of x by 2. 2 times of x by 2. That becomes 1 by sine x, and that is nothing but cosec x. So you have two options. Negative also, we don't take negative. Answer is option A. C here, A here. This is a simple question, right? This here is a simple problem. Have a look. Question number 3 is clear. Next up, question number 4. X times of root of 1 plus y times the root of 1 plus x. Find the derivative. Find the derivative. Okay, sir. So I'll do one thing. I'll write y times of root of 1 plus x over here, and I'll write minus x times of root of 1 plus y. And we'll do what? Yes, you're thinking right. Squaring both sides. Squaring both sides. We'll have y square 1 plus x square 1 plus y. To the expansion, we'll have y square plus xy square. Here you'll have x square plus x square y plus x square y. Okay. Can we move it over here? And this on this side, I'm gonna have y square minus x square, and this becomes x square y minus xy square. Take here the formula is there, y minus x and y plus x, and over here I have xy common, right? So I'll have x minus y. X minus y. Am I right? X minus y makes sense? Please check. So we have okay, if I take xy common, I'll have x over here, and this is simply y. Correct. So if you look at this, since they are not equal, it means x minus y is not equal to 0. This is very important. Usually what happens, we are in the habit of cancelling it. Good. But always look whether they are given equal or not. Because if x is not equal to y, then you move y on this side, it will become x minus y not equal to 0. Only then you can cancel, bacha. Okay? Only then you can cancel. Otherwise, you can't cancel. Because if it was 0 and 0, can you cancel 0 and 0 on both sides? You can't cancel, right? So if it is non-zero, then only we can cancel. Now if you cancel this and this, you'll have the answer as minus 1, because it is x minus y and y minus x. If it was both x minus y or both y minus x, then we can cancel and simply have the answer as 1. But here different sign is there. Okay. So I'm getting y plus x equals to minus xy. Minus xy. Okay. I'll rearrange everything. So I'll get y plus xy is equals to minus x. Take y common. You'll have 1 plus x equals to minus x. So y is equals to minus x upon 1 plus x. Y is equals to minus x upon 1 plus x. Derivative of this will have whole square in the denominator. That's for sure. Means it will be a or b. It can't be c and d. This is going to be an example of quotient rule, right? This is an example of quotient rule. Let me show you. Y is minus x upon 1 plus x we have. Okay. Alright. Yeah. So let me rewrite this as minus x plus 0 upon x plus 1. Derivative of this is given by x plus 1 the whole square, and over here minus 1 minus 0. What is the answer? Minus 1 upon x plus 1 the whole square. How come? I have taught you this formula, this trick I have taught you. If you have ax plus p upon cx plus d as a function y, then derivative is given by AD minus BC upon CX plus D the whole square. This into this, this into this. Check here. I had minus 1 into 1, that is minus 1, and here we have 1 into 0, that is 0. So we get the answer as minus 1 upon x plus 1 the whole square. Right? Correct? So answer is option B. Answer is option B. I hope it makes sense, guys. Yeah? Alright. Question number 5. The greatest integer function is continuous at non-integral values. This is clear. So answer will be option B. Because we have seen they have a break at the integral values, right? If you remember the graph of the GIF of x, the graph of this function, closed here, open here, closed here, open here, closed, open, and so on, right? So at all the integers value, this is going to be having a break, so discontinuous. Clear? Okay, next is question number 6. Yes, sine inverse of 2x upon 1 plus x square. How would you solve this one? I have asked you all to remember this form, 2x upon 1 plus x square. If I have not asked you before, please remember this form. This is a formula for conversion of double angles between sine and tan. Okay, so if you assume beta here x as tan theta, this turns out to be 2 tan theta upon 1 plus tan square theta. That is the formula for sine 2 theta. Okay, so the question is nothing but sine inverse of sine 2 theta. So y equal to 2 theta. If you check from here, theta will be tan inverse of x. So y equals to 2 times of tan inverse of x, and that gives me answer derivative. If you look at it, 2 upon derivative of tan inverse 1 upon 1 plus x square, and that's my option number B. Option number B. Please have a look. Fx equals to e power x and gx equals to log x. Then derivative of fg of x at x equals to 1 is how much? Derivative of fg of x at x equals to 1 is what? Okay. Now let's look at this first. F will have to find fog first, right? So let's find fog. So we'll write fog as, in E we'll put x as g, right? So we'll put here e power gx. So gx is what? Log x. This is clear. E power log is what? The x itself. So fog value is coming as x. They're asking us derivative of fog. Derivative of x is what? 1. Derivative of x is 1. So answer is B. Answer is clear as option B. Make sense, guys? Yes. A very simple problem. Y equal to cos inverse of 2x upon, again I told you, whenever you have this form, remember it. 2x upon 1 plus x square is there. Take x as tan theta, and 2 tan theta upon 1 plus tan square. Is that what we have? Yes, 2 into tan, 1 plus tan square. This will be sine 2 theta. This will be sine 2 theta. Sir, but we have outside cos inverse. No problem, let's just try first. Let's just try first cos inverse of sine 2 theta. Is that what we have? Right? Sir, we have cos inverse outside. It will be much easier if we have inside as cos only. Then make it. Make the bracket inside as cos. So we'll write this as cos of pi by 2 or 90 minus 2 theta. Because we know that very well, cos 90 minus x is what? Sin x. So we get this again, pi by 2 minus 2 theta, that's y. Write one more time, pi by 2 is a constant, minus 2 times of theta will be tan inverse of x. If you differentiate it, this will become 0. That will become 0, and 2 upon 1 plus x square is what we have. So answer is what? Option B. Answer is what? Option B. Clear? When you had sine inverse outside, the answer was 2 upon 1 plus x square. But when you have cos inverse outside in the same expression, the answer is minus sign because of applying the rule of complementary ratios. Complementary ratios. Next, derivative of log of mod x. We have y equals to log of mod x. Derivative of this will be what? So first of all, mod x has two definitions, x and minus x for positive, for x being positive, for x being negative. That's what the mod of x has the definition as. Alright sir, but provided whatever it is, okay, understand this, answer will be 1 by x only. Derivative will be 1 by x only. Whether x is negative or positive, answer will be same thing in derivative. But many of you might be thinking, sir, this is true only for this value, because if you look at the graph of log, this is the graph of log, it's defined only for positive value of, correct? If you are thinking that, sir, graph of log is this, it is only defined for positive side of x, isn't then option A is the right answer? No, because even if I take x as a negative value, let's say minus 2, I take x as minus 2, because of presence of over here modulus, this mod will make it what? Plus 2. This will make it what? Plus 2. So for that reason, the answer will be possible to find out. So if you look at option A and option B, first of all, these two are gone. Don't look at option C and option D. Option A and option B are the right options, right? Because the result will not be in modulus, right? So over here, this answer you check, this answer you check, is plain and simple, saying only true for positive side. But they have already applied modulus over here. It means even though it is negative, I will have the answer positive only. So my answer will be what? Option B. The answer will be option B. And of course at 0 will be not defined because log of 0 is not true. It does not exist, out of the domain. Question number 10 now. Okay, problem number 10. Fx is given as 1 minus cos x upon x square. They are supposed to check the continuity. For it to be continuous at 0, find the value of k. For it to be continuous, the condition is limit of fx when x tends to 0 should be equal to f of 0. F of 0 is given as k. This value is given as k. So we need to find the limit value. So let's start. Limit x tends to 0 we have for 1 minus cos x upon x square. Is that what we have? Yes, sir. We can simplify this. This is very easy actually. Again, you all can use L'Hopital rule also over here because this is a MCQ. Whichever gives you a faster result is up to you. But let me give you this answer using standard limits only. It will be very easy. 2 sine square x by 2 is the formula for the numerator. We have x. What do we have? We have x square. What do we have? We have x square in the denominator. For it to be following the condition for standard limit, I must have over here what? If this is x by 2, I should have here also x by 2. So something I have added over here extra, which is 2 square. So write same over here also, that will be 4. Cross check. Here we have 2 square, which is 4. They'll cancel, getting back to x square. Correct or not? This is something extra I've added, and this is the formula I've written for 1 minus cos x as 2 sine square x by 2. So I have done 2 steps over here. Formula of half angle, and this is simply writing 4 into 1 by 4 and putting this in the whole square. Cancel this. Continue the limits. 1 by 2 is a constant. I'm getting limit x tends to 0. What do we have? Sine square x by 2 upon x by 2 the whole square. This answer is what? Basically square of 1. Square of 1 is how much? 1 only. So my answer is coming as 1 by 2 into 1. That is going to be 1 by 2. And we said this limit value should be equal to the k. So k value is equal to what? Option B, which is 1 by 2. I hope each and every step is clear to all of you. Because this is a very important concept. Okay, use of limits and use of continuity definition as well. Use of limit as well as continuity definition as well. Let's move on to question number 11. And do not forget to let me know how was this session. Let's means if I can do something, bring out different type of questions, different number of questions, some easier ones, some more difficult ones. So all the communication from your side, I can understand only when you let me know that in the comment section. Okay, and of course for the notes and everything, lectures, rewatching the lectures, notes or assignment questions, tests, doubts, all of it is available for free, guys, in our platform, all in one platform. Link you will find in the description given, as I have already shown you also how to access it. Go check the demo part as well. In this class I have shown. Click on the link. It is very simple. Log in and start learning using the platform. Again, don't worry. I'll show you one more time after solving few questions. Okay. Yeah. The function fx equals to mod of sin x is not differentiable at. So there's many ways to solve this question. Right? Since critical point over here will be multiple. There will be multiple critical point. That can be visualized for people who understand what is the meaning of critical point. Critical point means about which point will the function change its sign, plus minus. In the case of modulus function, not in general. So in the case of modulus function, what is the point, what are those points where the function will change its sign from plus to minus or minus to plus? That's called as critical point, because there only the negative will be made positive, because modulus has only one role. Whatever is negative, make it positive. So the point where it is negative, that becomes a critical point. So we'll know that will be about what? The value 0, because right after 0 value is positive and before 0 the value is negative. Any function which is given to you will change its sign when it becomes 0. After 0 it is positive and before 0 it is negative. So ask yourself, everybody, ask yourself, when is sin x 0? What is the question to ourselves? Let's ask ourselves. What is the question? When is sin x equal to 0? When is it? So when x is, sir, 0 or pi or minus pi or 2 pi or minus 2 pi or 3 pi minus 3 pi, isn't this basically n pi, where n is all integers, right? 0 pi minus pi, 2 pi minus 2 pi, 3 pi minus 3 pi, 100 pi minus 100 pi, aren't these all integers? So we can write this as n pi. So my answer is what? N pi, where n belongs to integers. This is the logical way to solve it, which is correct, absolutely spot on, correct method to solve it. This was the question that we had to ask ourselves. What about other way, sir? Is there a better way? I personally love the second method, and that is draw the graph of sin x. Sir, you always say keep drawing the graph of sin x. Yes, or any function as says. Yeah, I love graphs. Okay, and still I am trying to learning most of them. Okay, I know few. I would love to learn more and more, because it makes our life much easier as a student, as a teacher as well. This is the sin x graph. When it says modulus, what it means? All the negatives should come to positive side. So bring it over here. And what about negative, sir? That will be deleted. I'll try to delete it. Yes, 1 second. Yeah. This is the graph of mod of sin x. Graph of mod of sin x. You can see where is it changing its sign? This is 0, pi, 2 pi, 3 pi, 4 pi, minus pi, minus 2 pi, minus 3 pi, minus 4 pi, and so on. The function is not differentiable when it has sharp corners or not. Yes, sir. Aren't these given options to you? This, can you see? 1, 2. Aren't these sharp corners, guys? Aren't these sharp corners? Yes, sir. So for those sharp corners, simply I will have the function as non-differentiable. The function as non-differentiable. That's what this was making a point. When it changes the sign, modulus will change its signs. It will become like this. That's why. Okay, so the graph part makes it much clearer, right? Yeah. Question number 12. Anybody has doubt in 11th one, ask that to me in the comment section. Let's see how many of you got it. Okay, let's see. 1 upon 1 plus tan x, then I'm looking for derivative of this. Okay, 1 upon 1 plus tan x is what we have. I want to differentiate it, so I'll need to differentiate using quotient rule only. So we're going to differentiate. 1 will be 0, so whatever it is, nothing, doesn't matter. Minus will keep 1 as it is, and differentiate 1 plus tan. We'll having sec square of x, and over here 1 plus tan x the whole square. What is this 0? This 0 is coming from differentiation of the constant 1. Okay, and this bracket represents 1 plus tan x. The bracket over here represents 1 plus tan x. 0 into anything will be 0 only, so I have not written that. What is my answer? Minus secant square upon 1 plus tan square. Option A. Yeah. Question number 13. Differentiate sin inverse 2x 1 minus x square for all mod x less than equal to 1 by root 2. Less than, not equal to, just less than 1 by root 2. Okay, sir. Let's try. Let us try. Okay. All right. Sir, I can see over here, if I take x value as sin theta, then 1 minus x square in the root will become cos theta, because this is sin square. 1 minus sin square is cos square, root will make it cos theta. So this expression that you have, y equals to sin inverse of 2 sin theta into cos theta, will be simplified now as sin 2 theta. That gives me answer as 2 theta. So y equals to, I have 2 theta, and theta will be what? Sin inverse of x. So 2 times of sin inverse of x. If you differentiate it, you're going to get 2 upon root of 1 minus x square, which is option number A. Option number A. Moving on. Question number 14. Second last question from the board style PYQs. Board style MCQs. Differentiating this. Okay, differentiate. It's not a difficult problem. This is basically a case of implicit function. This is a case of implicit function where the functions are given as the equation format, and we need to find the value of derivative. Differentiate. You'll have e power x as e power x. You'll have over here e power y dy by dx. In this case, e power x plus y as it is. Differentiate x plus y, you'll have 1 plus dy by dx. Let us do the expansion. So we'll have e power x plus y when you multiply with 1, and over here e power x plus y dy by dx. dy by dx. So I'll put everything, this part together. Okay, so this is as it is, e power x plus e power y. So I'll write this together, e power y dy by dx minus e power x plus y dy by dx, and this is nothing but e power x plus y minus e power x minus e power x. Okay, check carefully. This value is what? They've given us this is equal to e power x plus e power y. In the question they have given us right here, e power x plus e power y minus e power x. I have taken this part as this given in the question statement. E power x plus y as e power x plus e power y, the right hand side. Over here, if I take dy by dx common and I bring that term which is common, the bracket over here, I'll be left with e power y minus e power x plus y. Correct na? Take dy by dx common, you'll have e power y minus e power x plus y. Check. I'm having e power y over here, and what is this going to be? E power y, if you write it again, you'll have minus e power x left. Yes or no? How come, sir? Look carefully. Because e power x plus y is from here e power x plus e power y. E power y will be cancelled. You'll have e power minus e power x left. That becomes minus e power y minus x. Minus e power y minus x. Option D. A very, very, very good question. Okay? Something like this can be asked in CET also. Okay? Something like this can be asked in CET as well. To very good level of question. Okay? Yeah. Yes. Question number 15 now. Sir, what if we have fx as x mod x? No problem. We'll have two branching. When x is positive, you'll have x square, and when x is negative, you'll have x into minus x, that becomes minus x square. Graph of x square is this. Graph of x square is this. And graph of, this is the graph of minus x square. I need to combine both for this condition. So graph of fx will be what? Check. For the positive side, this will be the graph. For positive side, the graph will be only this part. And for negative side, the graph will be this part. This is the graph of given fx. So they are asking us differentiation at 0. You can find, no? You can find here will be 2x, here will be minus 2x. Both if you put 0 will be what? 0 only. So the answer is option C. Differentiation is what? Check here. Differentiate. If you want to see, differentiate. F dash of x will become 2x minus 2x when x is more than 0, when x is less than 0. Right here, this will be coming as 2 into 0 is 0, minus 2 into 0 is also 0. So answer is what? 0. Answer is 0. Correct? Yes. So this was the end of the 15 questions I took for board style MCQs. Few of them were good quality questions, can also be expected to come in CET as well. Okay? Yeah, let's solve some subjective questions, board style. Okay, from this chapter you can have 2 marker, 3 marker, 5 marker, all the categories are possible. Let's look at some of those questions. In 5 marker, just have the understanding, always second order derivative or parametric form application in second order derivative will come. I'll repeat myself because this is important. In the 5 marker section of your finals from this chapter, second order derivative or the parametric form application in second order derivative can come. Okay, moving on to board style questions. Now we have 2x plus 3 and 2x minus 3 supposed to find the continuity at the point 2. Okay sir, let's do it. Let us do it. Okay. And before I move forward, let me just save it once, because this file is very important to all of you, and this file you will get where? In your AIO page, all-in-one learning page. Okay, so don't forget to check out the learning platform. You'll find that given in free ACE KCET course 2027. So click on that link and access it. Everything is available over there. Okay, just that you need to create a login information. I'll show you how to create as well, but just try to check from there. Discuss the continuity over here. Okay sir, for continuity we know that we'll have to take equality from here, right? Because it's given as less than equal to. So let's find f of 2 first. F of 2 will be from here, sir. So we'll have 2 into 2 plus 3. That becomes 7. Before I write, let me just write the branching of the function once. For x less than equal to 2, the function is 2x plus 3. And for x more than 2, the function is 2x minus 3. 2x minus 3. Okay. Alright, that's going to be f of 2. Let's find. So here this will be same as the LHL, right? This will be same as the LHL also, because for LHL you'll have same branching available, so they'll be same. Yeah. What about RHL? So that will be different. Limit of fx when x tends to 2 from right hand side, that becomes a limit of the function fx right side branching is 2x minus 3. So write that. When x tends to simply 2, answer becomes 4 into 2 is 2 into 2 is 4 minus 3. How much is that? 1. Can you see that? Your LHL is not equal to RHL. This means fx is discontinuous at the point x equals to 2. At the point x equals to 2. Clearly mentioned over here, guys. Can you all see that? Yes. Next, find k for continuity of the given function. Okay. Yeah. X square minus 25 is given over here. Upon x minus 5 we have. So they mentioned that x is not equal to 5. It means I can factorize it. X minus 5 into x plus 5. So check, this will cancel because x is not equal to 5, which means what? X minus 5 is not 0. So we get the function as x plus 5. Basically, what is the function? The function over here is x plus 5. And again, at 5 will be open. At 5 will be open. Okay. So if you are finding, so we're looking for continuity, right? Okay. So we'll do one thing. We'll try to find here LHL equals to RHL. From here we'll find the value of, okay, means we have to find the value of the function at that point. Okay. All right. So let's find this. So for limit to be existing, we should have this condition f of 5. F of 5 will not exist because it says x cannot be equal to 5. It will not exist, right? Because basically if I draw this graph, let me show you. The graph will be like this. Okay, something like this over here and like this. This is the graph of the function. Because at x goes to 5, what will happen to the value? It will become undefined. That's why we don't put that in the function. There's an open part over here. That's the graph of the function. Okay, but if you cannot find this value, not possible, but you can find this value, because for the given function to be continuous, this is example of that what do you call, not jump. This is basically example of removable type of discontinuity. Okay, so over here if you find this value and define it over there, means if I define the function like this, again separately like this. For x not equal to 5, the function is what? X plus 5. And for x equals to 5, the function is what? K. Getting it? So if I redefine the function like this, for x not equal to 5, the function is what? This is the condition beta. Please check. For not equal to 5, the function is x plus 5. So we define the function again as k at x equals to 5. So let's find the value of k. That's what they're asking in the question. They're asking us for this function to be continuous, what value it will have if it is k. So I've redefined the function as k. Clear or not? This function graph is this. This is the graph of x plus 5 line. Graph of x plus 5 line. X plus 5 line, but at point 5 this is open, because at x equals to 5 the function value is undefined, it's not defined. So I've kept it open. If it is not visible, I'll give you another color. This is open, guys. This value is open over here. But I cannot find f of 5, but I can find LHL and RHL value, and if I separately put that value as equal to f of 5 as k, then the function becomes continuous, right? If the given function is continuous, then this value should be equal to f of 5, and that I've taken as k over here. So let me find the limit value. I can take either of them. Let's find limit. X tends to 5 minus, I'm finding LHL. What is the function going to be? X plus 5 only, because when x is not equal to 5, the value is x plus 5. Put here. We'll have 5 plus 5. How much is that? 10. This is the value of LHL. Go with RHL also, just to be sure. Check for RHL also. You'll have to approach limit x tends to 5 plus. I am assuming this you must have learnt in PU1, right? How to find limits. When this is having a gap. This is a very standard question. Okay, so you get the answer again here also as 10. Can you see that? This represents your RHL value. So for a function to be continuous, I should have LHL equal to RHL equal to f of 5 equal to how much? K, which should be equal to what? 10. This point you see over here is 10. The function value right after also is 10 and right before also is 10, and at the value 5 is not defined. That's why we put the value, redefine this as k equal to 10 to make it continuous. To make it continuous. Sir, how is it possible? If you put it as 10 means this will be only true if it is equal to 5, right? True. I'm not finding directly the value of this. I've assumed it to be a constant, unknown value. I've assumed it to be unknown value. What I've rather done is, I've tried to approach 5 from left hand side. This is giving me the value for LHL, and from this hand side. Both is giving me the value of, understand this, the point where you're finding the limit, it is always written as x tends to 5. But what you get outside, means what you get the limit value is always a finite value. What it means, I'll show you, 1 second. So if you write limit of fx, you never write x equals to a. X equals to a means basically x not equal to a means what? X tends to a. When I write x tends to a, right? Whenever I write x tends to a, this has a meaning. Excuse me. 1 second. Whenever you write x tends to a, this has a meaning. What is the meaning? X is not equal to a. That's the first condition. If I write x tends to 2, it means x is not equal to 2. It is just close to 2. Either right close or left close. Either close from right side or left hand side. That is different. But not equal to 2. So for that condition, so whenever we write limit, this is not equal to a, but this will, let's say if it comes as k, this k will always be a finite value. Always a finite value. Because if you are saying me that, sir, when you drew this graph, sir, you're saying that at x equals to 5, this value is not defined, but you are saying, sir, if you approach this value from right hand side, Ankit sir, you are saying, if you approach the value from right hand side, the value will become 10. How is it possible? Because it is open over here. As I said, limit value is always a finite value. Even if you are approaching from this side, right, it looks open, correct? But when you go in the function, the answer comes directly as 10. It is not 10 to 10. This value is not tending to 10. No, this is wrong. This is equal to 10 in the previous question. Excuse me. Clear? This is never tending to 10. We never write limit value tends to 10. We write x tends to that value a, doesn't matter. But we never write limit value tending to 10. Because limit is always a finite value. Okay guys? So for that reason, LHL and RHL both becomes equal to 10. And if that is the case and the given function is continuous, it must be the case of that this constant k should also be equal to 10. I hope this is clear. This is very important. I did some extra to teach you over here, but I understand many of you might know this already from your PU1 or grade 11, right? This is very basic concept of limits. This is from where the limit starts in PU1 or grade 11. Prove fx is not differentiable at the point 1. We can do that. Fx is given as mod of x minus 1. Define it again. You'll have x minus 1 for all value more than 1 and 1 minus x for all value less than 1. Less than 1. Let's find the left hand limit, right hand limit. Acha, we have the value f of 1 is equal to 0. Acha, we are looking for non-differentiability. Sorry. This is not required. This is not required. Okay, let's find left hand derivative. So limit when x tends to h, f of 1 minus h minus f of 1 upon minus h is what we have in left hand derivative. That's the expression. Sorry, I missed this. My mistake. H tends to 0 will be there now. Yeah. Put the value in this part. You'll have 1 minus h minus f of 1 will be what? 0 upon minus h. Continue please. Check here, this 1 and 1 will cancel. You'll have simply answer as plus h, because this will become minus and minus, so plus h upon minus h. You still have limit h tends to 0, but this cancels. You have the answer as minus 1. So left hand derivative is what? Minus 1. Let's quickly look at the right hand derivative also. We'll have same limit h tends to 0, but over here we'll have f of 1 plus h minus f of 1 upon h. If anybody is confused how I'm getting this is the standard form, no, for the left hand derivative, right hand derivative, f of a plus h minus f of a, right? Okay, in left hand derivative this is minus h, this is plus h. Okay, since this is a subjective question, no, that's why I'm doing all the steps. All right, yeah. Put the value over here. Limit h tends to 0, f of 1 plus h if you have, you're gonna put in this case, right? Yeah, you'll have 1 plus h minus 1. F of 1 is 0 anyway, and over here we have h. Why I'm putting over here? Because when you do left hand derivative, you have to use the left branching, but for right hand derivative, you have to use the right branching. Okay, the function is like that. 1 and 1 cancel again. You have the answer over here as limit. Only h is left, h by h when h tends to 0. The answer is simply this cancels, right? So we have only 1. You can see the right hand derivative is 1, left hand derivative is minus 1, which means they are not equal. They are not equal. It means the given function is not differentiable. Please write at the last one statement, fx is not differentiable at the point x equals to 1. Yes guys, clear? Makes sense? Let us move on there. Differentiate log of 1 plus x square with respect to tan inverse of x. This is differentiation of a function with another function. Let's say this is function f, this function g. They're asking us d of f with dg basically. Okay, so we'll do this d of f with dx upon d of g with dx. We'll have this differentiation as 1 upon 1 plus x square, and differentiate this, you're going to get 2x. Right? Log derivative is this, and derivative of this bracket is 2x. Let's do dg by dx also. We have tan inverse, that becomes simply 1 upon 1 plus x square. Derivative of tan inverse is simple. We want ratio, right? We want ratio, so take ratio here and here. Check. This part will cancel. This part will cancel. So my answer is coming very clearly. This ratio is just how much? df by dg. Answer is coming as df by dg, and this becomes what? Only 2x. This answer is only 2x. Clear? Alright. Next. Question number 5. Y equal to sine inverse of x, prove that. Okay, this is the condition. Actually, look this carefully. This is the second derivative. Second derivative. Alright. I'll write this as y1 if you don't mind. I'll write this as y equal to derivative as y1 and y2. I'm going to get this as 1 minus x square. Square both sides, guys. You'll end up with y1 square equals to 1 upon 1 minus x square. Now cross multiply. You'll have 1 minus x square, y1 square equals to 1. Differentiate now. Differentiate this, you'll have minus 2x y1 square. Yeah. And then you're going to have what? Plus this as it is, and differentiate this value. You'll have 2y1, y2 equal to 0. You can see something is common. You can see something is common, that is 2y1 is common. Check here, 2y1, 2y1. So I'll write this part first. 1 minus x square comes. This is as it is. If you check, only y2 is left. Only y2 is left in the second term. And here we have minus x y1 left. Correct? Because I've taken 2. This is y1 square. I've taken 2y1 common. We know derivative will be not equal to 0. Check here. This is a non-zero value. This is a non-zero value. So I can divide this on this side. My answer becomes 1 minus x square. y2 means d square y upon dx square minus x times of dy by dx, and 0 upon that 2y1 becomes 0 only. So this is the statement proved. Have a look. Statement is proved. Second order derivative question. Second order derivative, very simple problem. This is the question on parametric form application with second derivative. To find this, you have to find the dy by dx first. And they are both in terms of parameter. So we'll write dy by d theta upon dx by d theta. Okay, sorry, I had some interruption. Let's solve it now. So, yeah, differentiate y and x both with theta. So let's find this value over here, dy by d theta. Y is here, a is a constant, keep it outside. One derivative will be 0. Cos becomes what? Minus of sine theta. Right? That becomes a sine theta. That becomes a sine theta. Okay? Same way, differentiate this. So if you write dx by d theta again, you'll have a as a constant as it is. Theta will become 1. This will become cos. So you're getting 1 minus cos. Okay. Ratio now. So ratio part will give me something. Check carefully. You'll have the value over here as a sine theta upon a 1 minus cos theta. This cancels. Sine is theta is nothing but 2 sine theta by 2 into cos theta by 2. Half angle formula of sine theta. That's for sine. And for 1 minus cos, what do we have? 2 sine square theta by 2. So this 2 and 2 cancels. This also will cancel this. We're going to end up with cos theta by 2 upon sin theta by 2. Am I right? Yes. Correct. This becomes cot theta by 2. That's my dy by d theta. Sorry. So this is wrong. This is dx, right? That's dy by dx. I've taken the ratio, right? Now I want to find the second derivative. This is simple. Differentiate cot. You'll have minus cosec square theta by 2 into half derivative of theta by 2 into d theta by dx. d theta by dx. Okay. So we have the value. Check here. d theta by dx will become 1 upon a. This was how much? 2 sine square theta by 2. Correct? Alright, let's accumulate all of this over here. Let's write all of them together. Dx square. So we are getting minus. Check. Yes. Correct, no? D theta by dx will be 1 by 2 a2 sine square theta by 2. That's correct. And this is as it is. Anything is wrong. Cot becomes minus cosec square theta 2 by 2 becomes 1 by 2. So let's write this part first. Minus cosec square theta by 2 divided by 2, and we have over here d theta by dx. Yeah, then we'll write that value. Minus 1 by 2 cosec square theta by 2 into 1 upon 2 into a sine square theta by 2. Correct? 1 by 2a sine square theta by 2. So I'll take this also in the numerator only. Getting the answer as minus 1 by 4a. 2 into 2 is 4, a as it is. This will also become cosec square, so it becomes cosec power 4 theta by 2. This is my answer. D square y upon dx square. Question like this, if it comes for 5 marks. Yeah, please have a look. Question number 6. Application of parametric form in second order derivative. Clear? Clear? Question number 7. This is a very common question. This is a PYQ also. When they provide the function in this form, y equal to, they have given cos x into cos 2x into cos 3x. What we do? We take log on both sides, right? We take log here and here. When you do that, it happens what? Log y equals to log cos x. Log, you're going to write log cos x, log cos 2x, log cos 3x. Basically log of the product. So you'll have the formula in terms of product 2 sum. So plus differentiate, you're going to have what? 1 by cos, and cos becomes sine, minus sine, so minus tan. Same for this also. 1 by cos 2x minus sine 2x, and derivative of 2x is minus 2, so minus 2 tan 2x, and so on. And bring back this y on this side, so you'll be simply multiplying with this result. If you want, you can simplify over here as dy by dx equals to minus cos x cos 2x cos 3x times of tan x plus 2 tan 2x plus 3 tan 3x. By simply taking the minus sign common, nothing else is there. Rest all is same. Okay, correct? Very common question. In the log differentiation of 3 marks question, this comes. Next, they've given this question to us. They're asking us to find the derivative. Tan inverse of, okay, tan inverse of this. Tan inverse of, we have root of 1 plus x square minus 1 upon x. Upon x. Okay, sir. That's right. So if I take x as tan theta or cot theta, that's what we can do in this question, right? X as tan theta or cot theta. Let's try to do x as cot theta, if I do x as cot theta, then 1 plus x square becomes cosec square theta. Root will give me what? The value as simply cosec theta. So I'm getting this answer so far as tan inverse cosec theta minus 1 upon, what is this? Cot theta upon cot theta. Expand it, guys. Cosec is 1 by sine theta minus 1 upon cos theta by sine theta. Okay. Okay. Yeah. It'll be easier if I do cos, right? Because 1 minus sine will be what? Cos minus sine the whole square. Okay, we'll try, no problem. We'll try that. It'll be easier actually if I do that other way. I'll show you that also, don't worry. So if you take LCM, it'll be easier if I take x as tan theta actually, but no problem. This becomes 1 minus sine theta upon sine theta upon cos theta by sine theta. Sine cancels, so I'm getting the result as tan inverse of 1 minus sine theta upon cos theta. So if I take x as tan theta, no? If I take x as tan theta, then this will become 1 minus cos upon sine. That will be faster to solve basically. Okay, so let me show you that also. If I take x as tan theta, then over here you'll have y equal to tan inverse of 1 minus cos theta upon sine theta. Trust me on this. Okay, do this proof. All this is substitute. You'll get 1 plus tan square will be sec square. So sec theta minus 1 will come. This will be tan. Sec is what? 1 by cos. It becomes 1 by cos. 1 by cos by cos. This will be sine by cos. Cos and cos cancels. So 1 minus cos upon sine will be left. Trust me on that. Trust me on that. You'll have this. And this is simple actually. I'll show you. This becomes 1 minus cos is what? 2 sine square theta by 2. This is what? 2 sine theta by 2 into cos theta by 2. Okay? Getting it? This is method number 2. 2 and 2 cancels. This also cancels. You have tan inverse of sine by cos. Thus tan theta by 2. We have one sine left, okay, over here. This is not. One second. We have 2 sine square theta by 2. This cancels. And this cancels. We have sine by cos. That's tan theta by 2. This answer becomes theta by 2. So if you take in excess tan theta means you'll get the result as, please check, this will become y equals to 1 by 2 tan inverse of x. So derivative is what? If y is 1 by 2 tan inverse of x, then derivative is simple. 1 by 2 times of 1 plus x square. That's my answer. This is simpler, right? But we can solve it this way as well. Let me show you. So over here we have to use some formula. This condition will be given by cos square x by 2 plus sin square x by 2. This is all for the 1, and for this you'll have minus, for this part you'll have minus 2 sin x by 2 into cos x by 2. What I've done, 1 as cos square plus sin square and sin as minus 2 sin cos. Okay, great. What about this cos, sir? For this you're going to have cos square, but this is not x, right? The formula I'm writing basically. Okay, this all is theta. Let me erase and write it again. One second. Little patience, guys. Cos square theta by 2 plus sin square theta by 2, and this is nothing but 2 sin theta by 2 into cos theta by 2. Okay, and this is going to be cos square theta by 2 minus sin square theta by 2. This is minus sign. One is cos square plus sin square. Sin is 2 sin cos, the half angle formula, and cos is cos square minus sin square. Check. So getting the value as, very beautifully, y equal to tan inverse of, in the bracket you'll have, check, a square b square minus 2ab. There's a minus sign over here. A square b square minus 2ab. It becomes a minus b the whole square. So cos theta by 2 minus sin theta by 2 whole square divided by denominator cos square minus sin square. What do we have? So we have over here cos theta by 2 minus sin theta by 2 into cos theta by 2 plus sin theta by 2. Check. This will cancel extra. So y equal to tan inverse of, what do we have? Cos theta by 2 minus sin theta by 2. Correct na? The whole square was there. So one of them I have cancelled. I am having one of them left. This is what? Cos theta by 2 plus sin theta by 2. Divide in this whole expression. This you divide everything by cos theta by 2. Try. You will have y equal to tan inverse of, check here, it becomes 1 minus tan theta by 2, 1 plus tan theta by 2. How come, sir? Cos by cos is 1, sin by cos is tan. There is a formula, tan inverse of, this becomes tan pi by 4 minus theta by 2, and this is going to be what? Please check. Y equal to, yeah, pi by 4 minus theta by 2. Differentiate it. Okay, theta in this case will be how much? Cot inverse of x. Okay, differentiate this result, differentiate, you'll get the same answer as this. So method 2 or method 1, your choice, guys. This is, as I said, no, once I realize it is coming as 1 minus sine. The trick is, understand, try to get always this as 1 minus cos. Is it easier? If you have 1 minus sine, you have to make a perfect square. If it is 1 minus sine, you have to make a perfect square. That is lengthy process. If it is 1 minus cos, the formula is there. Okay? So my recommendation to all of you, try to ignore this and choose 1 minus cos, because this is the formula given as 2 sine square theta by 2. If you have 1 plus cos, it becomes 2 cos square theta by 2. So I would recommend you to use this form or reduce the question in this form. So when I saw that in the problem coming as 1 minus sine, I knew it'll make it whole square, it'll be lengthy process. That's why I explained you the shortcut method or better method as method 2. Please choose method 2. Use method 2. Just what is the difference? Take x as tan theta. You will see in the question. This will become 1 minus cos upon sine. Clear, right? Both methods are clear. Okay. I'll just give you one more look. Yes, question number 8 starts from here. Very good question, by the way. Very, very good question. Okay. K for continuity. F of 0 is given. Let's try to find limit then. Limit of 1 minus cos 4x upon 8x square when x tends to 0. This is the easy question. Again, this is the formula. 2 sine square 2x, half of the angle, upon we have what? 8 is a constant, and can I write this 8 as 2 into 4x square? Yeah, check this out. In that case it becomes what? This 2 and 2 cancels, and you'll have the value over here as sine square 2x, and we have 2x the whole square when limit x tends to 0. This answer is what? 1 square. Answer is what? 1. And this should be equal to what? F of 0 should be equal to limit of the function when x tends to 0. This is coming as 1, this is coming as k, so k value is 1. K value is 1. Please check. Very simple problem. Yeah, correct. The last question in what? In your differentiation. If you have y equal to sin x power cos inverse of x given, how do you solve it? Which form does this resembles? This resembles the form of logarithmic differentiation. Take here, log y equals to log of sin x power cos inverse of x. So log y is equals to cos inverse of x into log sin x. Differentiate now. You will have 1 by y dy by dx. Here we have product rule. It becomes minus 1 upon root of 1 minus x square times of log sin x plus cos inverse as it is. This will be what? 1 by sin x into cos x. Derivative of sin is cos. Yeah, continue. dy by dx. I'll multiply y on this side. Let's write that first. It becomes cos by sin. That's tan x into cos inverse of x minus log sin x upon root of 1 minus x square. Can you see any chance of simplifying it? No. Just put the value of y back from here, the same value. Substitute from here. That becomes your answer. Here you go. Excuse me. Here we go. This is my answer, sir. Okay, clear? Simple problem. Moving on to the next question, which is going to be what? This over here is the end of your board style problems. Next is what? Let's solve some MCQs, 20 questions of the KCET style. KCET style problems. Let's solve this now. KCET style questions now. So first one says fx equals to, okay, so we have fx equals to root of 1 plus kx minus root of, that's right, upon x. F of 0 is given as 2. So put the value of limit fx when x tends to 0 as 2. We'll get the value of k from there. And how to find limit? Okay, there are multiple ways to find it. We'll simply utilize LH rule. Limit. We can utilize what here? The LH rule. L'Hopital rule we can utilize. Okay. Differentiate it. You'll have 1 by 2 root 1 plus kx, and over here you're gonna have what? K left, right? Differentiate this, you'll have k left minus, same way you'll have minus k left over here divided by 1 by 2 root 1 minus kx upon 1. Just to make sure that you understand, we have applied here LH rule, which is L'Hopital rule. Alright, sir, that's okay, that makes sense. Now if you substitute the value of 0 over here, you'll ending up with k by 2. Can you see k by 2 is constant? K by 2, I've taken it constant, the common. Okay, now put the value 1 upon root of 1 plus 0 into k. That's 0 only, and this will be plus sign because this is minus and minus, so plus, same. 1 minus 0, and we have this also as 1. This is basically becoming what? Check carefully. This is becoming k by 2 into 1 plus 1. So k by 2 into 2. That gives you the value as simply k. K. Put that back over here. You get k equals to 2. They're asking us to find the value of k. That is option number B. Option number B. Clear or not? Yeah? Come on. Question number 2 now. Derivative of log of x with the base 10 is what? Formula. Very simple formula. So you can either use the base change condition, or simply write this as 1 by x log 10. 1 by x log 10. Option is A. Formula is there. Log x with the base A is 1 by x log A. E power x. E power x. What is the answer going to be? Y dash will be e power x times of e power x. So answer is B. Some of them are very easy questions. Okay. Now this one, we just solved this question, right? X times of x square. So basically this is x times of x when x is more than 0. So this was also what? Minus x square. This is your fx. We just solved it right now. The graph, you remember, was this. Derivative over here will be 0 at the origin. So answer is what? Option C. Some of these questions are extremely simple. Moving on. Here, cos inverse of 1 minus 2x square. We want to find the root of this. So we have outside cos inverse, right? We have outside cos inverse. So I need to make cos inside. So I'll try to take this as. Okay, no, that is good. We have 1 minus 2x square, right? There is a formula. Do you recall? Yes. Take 1 minus 2 sine square x. This is the formula. 1 minus 2 sine square theta. Actually, I have taken x as sine theta. This is nothing but cos 2 theta. This is nothing but cos 2 theta. So put it over here. This gives me value as 2 theta, which means 2 times of sine inverse of x. From here, 2 times of sine inverse of x. Differentiate that, you'll have the answer as 2 upon root of 1 minus x square. 2 upon root of 1 minus x square, in which the option is B. Option is B. Next, log of sin x. Differentiating this, but we have to do it 2 times. So start with the first one. Y1 will be what? Sin x over here, and derivative of sin is cos. Log derivative is 1 by sin, and derivative of sin is cos. So this expression becomes cot x. I want to find second derivative. That's minus cosec square x. Differentiate the cot, minus cosec square x. Makes sense? Moving on. Here, derivative, second derivative at the value t equal to 1. Start with the first one. Start with dy by dx first. So you'll have dy by dt upon dx by dt, the parametric form. Differentiate this. You're gonna have t is 3t square. Differentiate this. You'll have 2t square. You will have 2t square. Right or not? Check this out one more time. 3t square and 2t, just 2t, not 2t square, my bad, just 2t. This cancels. You have the answer as 3 by 2t. 3 by 2t. This is very important, okay? This is very important. 3 by 2t is okay. Now check once. Dx by dt value was how much? Compare. This was dx by dt, right? So 2t. Dx by dt was 2t. So dt by dx will be how much? 1 by 2t. Right? Dx by dt is coming as, check from here, 2t. So dt by dx will be 1 by 2t. Now differentiate this again. Second derivative you find now. D square by dx square. This will become 3 by 2 dt by dx. Differentiate t, you'll get dt by dx. 3 by 2 as it is. This value is 1 by 2t. They have asked you to find the value at t equals to 1. So answer becomes 3 by 4. Answer is 3 by 4. Lovely question, but very simple. Parametric form and chain rule is the concept being utilized over here. Please have a look, question number 7. Moving on with question number 8. Again, they're asking us this given function is not differentiable at which point. So always remember, any modulus function or any modulus function's part will be non-differentiable at its critical value, at its critical point or value. And what does that mean? It means where that modulus becomes 0. So look at first modulus. This becomes 0 when x is 3 and this becomes 0 when x is 4. X is 4. So for both the modulus, you have 1, 1 coordinate points. You have 1, 1. So basically you'll have, okay, 3 and 4, right? Yeah. So you'll have minus 2x and plus 1, right? That's going to be, yeah, no, sorry, minus 2x minus 3. So plus 7 actually. This will become 3 and this will become 4. So minus 2x plus 7. Before this, so you'll have basically a straight line like this. This is the graph going to be. The graph will be this, right? If you start my x minus 3 over here after this, and over here you'll have minus x plus 4, that cancels. This is going to be 1, right? And after this, if you take, so 2x minus 7, this graph is minus 2x plus 7, and the other one is 2x minus 7, and this graph is what? Y equal to 1. This is y equal to this. This is y equal to this. So there are the 3 lines. You can clearly see in the figure where, of course, this point is what point? This point is x equals to 3. This point is x equals to 4. Right? How am I finding this? Before 3, both of them are negative. Before 3, both of them are negative. So this will be minus x plus 3 minus x plus 7. It becomes minus 2x plus 7. 3 plus 4 is plus 7. After 3, this will be positive, this will be negative. So x minus 3 minus x plus 4. So x and x cancels, and minus 3 plus 4 is 1. That is y equal to 1, the constant line, the horizontal line. And after 4, both of them are positive. So x minus 3 and x minus 4. Add them to x minus 7. So this is the curve. This is the curve. Right? This is the curve. So if this is the curve, okay, so basically if you want me to draw the perfect one where you have a Cartesian plane, this is your Cartesian plane basically. X-axis, y-axis is going to be 7 over here. Yeah, correct. So this is your final curve. You can find there are better 2 coordinate points. The one is 3 and 4. Acha, I gave that answer already to you as option C. This was for the curious mind. In your mind, student's mind, you'll have, sir, you said critical point. At the critical point, they are non-differentiable. Yes, we accept it. We need to solve the question faster. So the modulus critical point is when it becomes 3, when it becomes 0. So this is becoming 0 when x is 3. This is becoming 0 when x is 4. So yes, the answer is clear. But how? This what I wrote is for the student who thinks in the way of how. You don't need this information in this particular question. What you need is modulus is having a sharp corner, or it changes the sign when it is at its critical point. 2 modulus are there, 2 critical points are there. That's why the answer is option C. This is for student who wants to understand how it is non-differentiable. Corner point, corner point. 2 corner points are there. 9. Differentiation of sine of tan inverse of e power minus x. This is a simple question of chain rule. Differentiate sine first. It becomes cos. That's for cos derivative of sine. Differentiate tan inverse now. You'll have 1 plus this square. Differentiate this last function now. You'll have e power minus x. Differentiate minus x now. You'll have minus 1. Check which option is suitable. So we want minus e power. We want minus e power minus x from here times of cos of tan of e power minus x divided by 1 plus e power minus 2x. Because 2, this is power is there, right? So minus x into 2 is minus 2x. B is correct. B is the right choice. I don't think anybody will have doubt in this. A very simple problem. Next. If y equal to 1 minus cos x upon 1 plus cos x is there, then find the derivative. Difficult problem? I told you, whenever you have this 1 minus cos x, 1 plus cos x, be happy, this is a formula. 2 sine square x by 2, 2 cos square x by 2. We have a formula for this statement. Put it over here. Y equal to 2 sine square x by 2 and 2 cos square x by 2. 2 and 2 is cancelled. What do we have? Tan square x by 2. I think something is wrong over here. Yeah, sorry, my bad. There must be a root in the question. Because if I differentiate this, let me show you. If I have this y equal to tan square x by 2 and I want to differentiate it, you'll have the answer as 2 tan x by 2. Differentiate tan, you'll have sec square x by 2 and into 1 by 2. This cancels. So my answer is what? Tan x by 2 into secant square x by 2. Let's look at the options that you have. None of them are like that. It means, and actually I missed it, there's a root over here. Now if it is a root, then answer will be correct. Check. It becomes tan x by 2. Now once you have that, y equal to tan x by 2, differentiate it now. You'll have secant square x by 2 into 1 by 2. And that's my option number A. Clear the conditions? Y should be root. If it is not root, you'll work around like this. Okay. Next. Question number 11. E power x times log sine 2x is there. So we have to use product rule. Differentiate e power x. That will be as it is. This will be also as it is. Plus. Keep e power x as it is. Differentiate log now. So you'll have 1 by sine 2x. Differentiate sine 2x, you'll have cos 2x. And differentiate 2x, you will have 2. You can see e power x is common. This becomes cos by sine. That is going to be cot 2x. So 2 cot 2x plus log sine 2x. Cos by sine is cot 2x. So e power x 2 cot 2x plus log sine 2x. Which option is that? Yeah, that's option A. This right here is option A. Okay. This question. This is the problem which is not much in the requirement of solving than analyzing. If you can analyze the problem, You can solve it within few seconds, maybe 1 or 2 seconds. Tan of 1 by x is what? Tan inverse basically. Excuse me. This is going to be cot inverse. Then you have tan inverse. Answer is what? Pi by 2. That's y. That's a constant. Derivative will be what? Y equal to pi by 2 is a constant. Differentiate that. Answer is 0. Answer is 0. Makes sense, everyone? Tan inverse of cos x upon 1 plus sin x. Formula is there. 1 plus sin x we have. Yeah. So cos x will be, this is important one, just pay attention. Again, formulas, we should, once you know the formulas, right, half angle, double angle, you can play around different questions in different way. Cos x will be what? Check here. Cos square x by 2 minus sin square x by 2. 1 plus sin x is what? Cos x by 2 plus sin x by 2 the whole square. Formulas are there, but why, sir? The question is why? Because we need to reach outside, we have tan inverse. To simplify it or to make it solvable or easy to solve, I have to create a condition for tan inside, right? And this is a formula, direct formula. This is not a direct formula, but this, remember I solved a question back. One is cos square plus sin square. Sin is 2 sin x cos x by 2 basically. This becomes a whole square. The perfect square question, I told you use the other method, that problem. If you want, I can show you that as well. It's right here, right? 1 second. I can show you 1 second. Give me 1 second. The question was, which question was this? This one, right? Yeah. So if you have 1 minus sin theta, this becomes cos minus sin the whole square. But if you have 1 plus sin, it will become cos plus sin the whole square. So in this case, we have 1 plus sin, it will become cos plus sin the whole square with the half angle. Now again, divide which is common, we'll have here cos plus sin into cos minus sin. This is having 2 cos plus sin. So we'll have cos x by 2 minus sin x by 2 left. Here also same thing with plus sign. How come? This is a square minus b square, so cos minus sin into cos plus sin. This is cos plus sin the whole square. So cos plus sin I can cancel from both the numerator and denominator. Now divide by cos x by 2. Everything. You will have 1 minus tan x by 2 and 1 plus tan x by 2. This is the result, tan of pi by 4 minus x by 2. So my request to all of you will be, please remember this result. Please remember this result. If you are serious and if you want to solve this question faster, because this kind of question will appear in CET. So if you want to remember this kind of question, please remember cos by 1 plus sin x is nothing but tan of pi by 4 minus x by 2. Remember this two result. Once you know that, this question becomes very fast. Tan inverse of tan of pi by 4 minus x by 2. That makes it y equal to what? Simply pi by 4 minus x by 2. dy by dx will be what? 0 minus 1 by 2. Answer is minus 1 by 2. That's option B. I hope it makes sense. Please check. Yes. Question number 14 now. Question number 14. Y equal to a power x is there, son. Then find the second derivative for this function. Let's find the first derivative. A power x log a. Second derivative, this is a constant, right? Differentiate this, you'll have again a power x log a. What is my answer going to be? A power x log a the whole square. Log a the whole square. So answer is option A. The answer is option A. Please have a look. Number of points where fx equals to mod of 2x minus 1 plus mod of 2x plus 1 is non-differentiable. Now this time I'm going to use the direct principle. The critical points, that is enough. X equals to 1 by 2, x equals to minus 1 by 2. They're asking us number of points. So answer will be C. Right? The similar question, they were asking us at what points they are non-differentiable in the previous one. Here they're asking number of points. So answer is 2 points for 2 different given modulus. Okay? Yes. Derivative of log of x plus root of x square plus 1. Acha, if possible, try to remember this form. Okay, this is the standard form. Not a very direct one, but indirect one is there, and it becomes very useful. I'll show you. You'll see. Differentiate it now. So this will come in denominator actually for the first. And what happens? So this same thing repeats over here after differentiation. I'll show you. Differentiate x, you'll have 1. Differentiate this part, you'll have 1 by 2 root of x square plus 1. Then you'll have 2x over here. Chain rule will give me 2x. Differentiate x square plus 1, you'll have 2x. This 2 and 2 cancels. Check. Take LCM over here. You'll have x square plus 1. This becomes same thing. Plus x, right? This is cancelled. You have 1 upon x square plus 1. 1 upon x square plus 1. Derivative value, that's option A. That is option A. So basically in the forms like this, right, same thing comes back over here. Same things comes back over here. That's why the result of this derivative basically will be present in the answer. Try solving few questions like this, you'll get the understanding of this. Next. 16th one is clear, right? Let's quickly check one more time. Yeah. Tan inverse of 2x upon 1 minus x square. 2x upon 1 minus x square. Again there is a standard form. Take x as tan theta. You'll get what? Check. 2 tan theta upon 1 minus tan square theta. That's the formula for tan 2 theta. So derivative of tan inverse of tan 2 theta, derivative of 2 theta, derivative of 2 times of theta is tan inverse of x from here. So you get 2 upon 1 plus x square. 2 upon 1 plus x square. Why I'm going faster over here? Because actually I've done these questions in a different way or different type of form in the previous problems of MCQs in board style or subjective questions. Okay, that's why I'm going faster over here. But I request you to please remember these forms. They're very important in nature. Okay. Differentiating, I need to find the value of this expression. So start from derivative number 1. Y1 will be what? Y1 will be sine becomes cos. So cos of log x divided by x, multiply over here. X y1 equal to cos of log x. Right? Differentiate now. X will be 1, y1 as it is, plus x as it is, y1 becomes y2. I'm differentiating it again, the entire equation. This becomes minus sine log x upon x. Bring x on both the terms. We'll have x square y2. If I write this term first, then we'll have x y1 equal to minus y. Please check. This is going to be minus sine log x. So minus y. X square y2 plus xy1 equals to minus y. This is answer is option A. Can be asked this kind of question in MCQs also, but they don't ask it that of boards basically. I'm saying MCQs of boards they can also ask in the fill in the blank side. They can ask if they want to give a good question over there. Now over here, this can become a calculative problem if you don't use the options. Check. All the options has same denominator. All the options has same denominator. Okay. So if you take this property log a by b, you will have log a minus log b. Differentiate. So if you have, this is my y, so your dy by dx will be x square plus x plus 1 minus x square minus x plus 1. Now differentiated, you'll have 2x plus 1 over here, 2x minus 1, right? The derivative of x square is 2x, x is 1, 1 is 0. X square 2s minus 1. Okay. Don't worry about the multiplication over here. This is going to be the same because they are, of course, you have to take the product, do the cross multiplication. You'll get, multiply this. You'll have 2x cube minus 2x square, then plus 2x, and then multiply with 1, same thing will come, x square minus x plus 1. This is the first part. Second you check. So we'll have over here minus 2x square minus 2x cube, right? 2x cube. Multiply 2x with this, minus 2x cube. Then we have minus 2x square and minus 2x. We'll do with 1, you'll have plus 1 actually because minus and minus is there. So same thing will repeat. Plus x square plus x plus 1. Plus x plus 1. Check carefully. This cancels. Then we have x square and x square. That cancels one of this. Then we have 2x. This also cancels. Then we have minus x. This also cancels. What I'm getting now, I have only what is left with me is minus 2x square and plus 2. This is minus 2x square plus 2. You can take 2 common, it becomes 1 minus x square. 1 minus x square. Did I miss something? Did I miss something? Oh yes. What did I miss? Check. If I multiply, no, it looks correct only. It should be, option is what? Yeah, this is there, no? 2 into option A is correct, right? Just cross check, guys. The question number 19, option A is correct or not. Yeah. This is, we're not checking the denominator because everybody has same denominator. All the option has same denominator, so we are not checking that. We are checking only numerator. So this is coming like that, 2 into 1 minus x square. Let me just cross check once. So we have 2x cube minus 2x square plus 2x, and then this is as it is, x square minus x plus 1 because we're multiplying this with 1. If you're not sure, please do the calculation over here. Okay. Then we multiply with minus 2x, so minus 2x cube minus 2x square minus 2x, and this will be simply plus 1, so as it is, that cancels. This will cancel this x square, and that x square will come, see this x square and that x square cancel this minus 2x square. Then we have 1 over here, that becomes 2. This is there, x and x also cancels. 2x minus 2x also cancels. This is correct. Answer is here. If you're getting something different, let me know. Okay. Check once. If you have a different answer for question number 19, let me know. Answer is option A. 20th. X power sin x. X power sin x. Log y sin x log x. Log y sin x log x. This was not y, this is just simply y. Okay. 1 by y dy by dx. We'll have here cos x log x and plus sin x by x. So we have cos x log x plus sin x by x. Option A, right? This is minus sign actually, this is plus. I want plus sign, right? Because this will be a bracket. Then we're going to move y over here. Have a look. Yes. Clear? So these were your 20 KCET style MCQs. Let's move on. Now some PYQs of CET. This, if you have solved your board's PYQs, you'll know the answer for this question is option C. How come? Start from here. Differentiate. You'll have y1 2 tan inverse of x upon 1 plus x square. This comes from polynomial differentiation. The denominator comes from derivative of tan inverse. Cross multiply. Correct. Now differentiate this also. You will have y2 1 plus x square plus you'll have 2x times y1 equal to, differentiate again, 2 upon 1 plus x square. Move on this side, you'll have y2 times of 1 plus, if you move over here, it will become whole square. Over here it will become plus 2x times of 1 plus x square. y1, check, y2 1 plus x square the whole square, 2x times of x square plus 1 times of y1 equals 2. The constant which is left, 2. Answer was option C. Okay, sorry, this was also KCET PYQ, guys. My bad. All right. I put it in between actually. Should have started from there. Okay, I'll arrange that. Yeah. Okay, function represented by the following graph is, this is a continuous function at one point, which is, which point? At this point it is having a edge or corner, so it will be what? Non-differentiable. It will be non-differentiable at the point 1. Option A is correct. Option A is correct. Because of the sharp corner at the point 1, it will be non-differentiable at the point 1. Continuous? Yes. Fx is given as continuous. So when it says continuous, I mean LHL should be equal to RHL should be equal to f of 0. So I don't need to find both. I just need to find any one of them. let's find LHL. We can directly find limit only in this case. Limit 3 sine pi x upon 5x when x tends to 0 is what we have. Take the constant 3 by 5 outside. Limit x tends to 0. We have sine pi x upon x. For this to be a standard form, I am missing pi over here. So let's do pi there and multiply pi here extra. I multiplied pi extra. Bring this pi outside. It becomes 3 pi by 5. Now you go. Limit x tends to 0. Sine pi x upon pi x. We know that very well. This value is going to be equal to 1. This will be equal to 1. So your LHL or limit value is coming as 3 pi by 5 into 1. So as it is. This should be equal to what? F of 0. That's how much? 2k. So 3 pi by 5 equals 2k. Bring 2 over here. K is 3 pi by 10. K is 3 pi by 10. K is 3 pi by 10. Please have a look. Clear? Question number 4 now. Similar problem, exact same problem. We have to look for continuity at the point 5. So we're going to go with the same approach. Limit of 3x minus 8 when x tends to what do you call? Let's say I'm going with 5. Okay, let me do better. Because over here, no, we can rather find the value for right hand limit. So we'll have this value as, okay, right hand limit value is coming as from here. Please check 2k. And f of 5 is actually coming as directly 3 into 5 minus 8. That's 15 minus 8 is how much? 7. So if it is continuous means they must be equal. So I'm getting what? 2k equals to 7. So k equals to 7 by 2. We don't have to find the limit in that case because directly the function value is given. Okay. So answer is B. 7 by 2. Answer is B. 7 by 2. Okay. Clear? Clear, right? Next. We have again log. But we have quotient rule value condition. So we can write directly over here y equal to log of 1 minus x square minus log of 1 plus x square. Now differentiate it. Differentiate this. Right? You have over here this. Differentiate over here. You get minus 2x. Derivative of this is 1 minus x square. This becomes minus 2x. This and we'll have plus 2x. Right? Expand it. This is going to be 1 minus x power 4. This becomes minus 2x cube. Multiply over here. Cross multiply. This over here becomes minus 2x plus 2x cube. So this and this cancels. Minus 4x upon 1 minus x power 4. Option is C. If you feel that any step in the calculation you need to do again, please go ahead and do it. Okay? Again, I'm helping you to understand the questions. You need to solve all these problems again. Just by watching this session, just by downloading the PDF of the class, you will not be able to solve all the problems of continuity and differentiability, which is one of the highest weighted chapter, among the highest weighted chapter of your syllabus. Right? So to master this chapter, you need to solve the problems with me. Either you're solving it right now, good, pause and solve, try from your side, or solve it later once you're done with the lecture. Once you've completed the lecture, you have to take out the time to solve the questions. Again, very important. Just watching will not be enough. You need to practice the problems, you need to solve the questions. That's how you learn any particular concept. So please take it seriously and do it from your side. Next, parametric form in derivative. Differentiate this. You'll have a 3 sine square theta. This is all for polynomial nature, which is power 3. So 3 sine square theta. Differentiate sine also. You'll have cos theta. Same over here. A 3 cos square theta. Differentiate cos, you'll have minus sine theta. A cancels, 3 cancels. This 2 will cancel this sine. This will cancel this 2. You'll have minus sine by cos. Minus sine theta by, that's how much? Minus tan theta. They're saying find 1 plus this. It means 1 plus tan square. This is minus, but square it up. It becomes positive only. And that is the identity 1 plus tan square as secant square. Option D. Please check. Option D. Next, application of determinant in the derivatives. So find the determinant P first. You'll have x square minus 1. Determinant of Q, or the determinant Q, you'll have x times of x square minus 1. You have minus 1 times of, check, x minus 1, and you'll have plus 1 times of, from here, 1 minus x. Expand here, guys. X cube minus x plus 1, 1 minus x. X cube minus 3x plus 2. That's q. They have asked us to find dq by dx. You get 3x square minus 3. 3 is common, x square minus 1. From here you get 3p. Clear? Clear or not? Please check. Yes. Question number 8 now. The question number 8 is a definition based question. Read the question, definition is clearly. The function fx equals to greatest integer function x denotes the greatest integer which is going to be less than or equal to x is continuous at non-integral value. Integer, integer, integer. This is the only non-integer. Answer is this. Some of the very straightforward questions are also have been asked in the past in the chapter. Over here, x power y equal to e power x minus y. We are supposed to find the derivative. Take log. So you'll have y log x equals to x minus y log e. If you take log on both sides and apply the property of log where the power comes as the coefficient, this y will come as coefficient, so y log x and x minus y also comes. Log e is what? 1. So y log x equals to x minus y. Let's write y terms on the same side. Take y common. So y equals to x upon 1 plus log x. Differentiate it now. Differentiate it now. You'll have the denominator always as 1 plus log x the whole square. Whatever is numerator, when you solve in with the rule of quotient, which is the quotient rule, this is taken as whole square, that much we know, right? In that case, look at the options. We have only one option which is having the whole square in the denominator, right? What about this, sir? This you can solve, right? Differentiate numerator, keeping denominator as it is. Next time put a minus sign and differentiate the denominator keeping numerator as it is. So do that, solve this, you'll have the answer as option C. Okay, sorry, I went back. Question number 10. This also is a question of logarithmic differentiation. How do you solve it? You'll take log on both sides. Okay, so you'll have log of x power m plus log of y power n, m plus n times of log of x plus y. Over here you'll have m log x plus n log y equals to the same thing. Now differentiate this, okay, and simplify by taking dy by dx on one side and taking it common, solving for that equation. You'll get an answer. Or remember this condition: whenever you have this basis in product and here basis in sum, same over here, base in product to sum, okay, sorry, power also the same way. Derivative in these questions is this. Always do this. So if you know the property, you get the answer in 1 second. Otherwise, it will take at least 2 minutes to solve this question. 1.5 minutes minimum, if you're very good. Done? Clear? Differentiate this now. So this is tan inverse. Take tan on both sides. So this will become x square plus y square. Tan of tan inverse is this itself, and tan of alpha will be just as it is. Differentiate now. 2x, 2y, dy by dx. This is a constant, so 0. dy by dx becomes, check here, this goes over here, minus 2x upon 2y. That's minus x upon y. Option is A, guys. Option is A. So I hope you have realized now how important is this notes, how important is this class, watching it again, practice questions on these topics again. And how can I do that? So let me, before I proceed and show you how can I do that, let me save this file for you. The class is not over, by the way. Wait a second. I want to show you how to access our all-in-one platform, which is about, which has everything that you need to do to learn seriously. And this is all for free. There's no charge in any of this. Just a second, guys. Give me a second. So if you come over here, check. So I've opened a sample session over here. You can check in this video's description also. Go and check the video description. You'll find over here, register. Okay, you'll find here, join the free ACE KCET 2027 course now. Chanjik, free ACE KCET course now. Click on that and this web page will open. This platform will open. Come, click on buy now. Basically, you can see there will be no price over here. If you click on buy now, it will ask for you to create a login information. Login credentials means your number, OTP. I have already done that and logged in with that. So if I click on buy now, it will open my course because I've already taken up from my side. Okay. Again, this is for free. There's no charge regarding that. So this is going to be your learning platform. YouTube course ACE KCET 2027. Click on that. All the lectures that we have conducted on YouTube will be available over here, subject wise and everything. Click on that. Let's say I want to learn maths. Come here. Click on this. See, all the lectures are over here. All the lectures are over here. You'll find your, class slides, notes, questions to practice, assignments. You can ask your doubts also over here in InstaSolve. Let's say you have a doubt. You can ask our own AI agent, that is Ved. You can ask a lot of your doubts over here. So everything that you need to learn seriously has been provided over here to all of you. I hope this is clear, guys. I hope this is clear how to use our all-in-one platform to make your learning easier and better, and all at no cost. Okay? No cost, no hidden cost. Alright. Tan inverse of sin x plus cos x, cos minus sin. We're looking to find the value of derivative. Start from here. Achha, before I do that, this is a form actually, right? We have cos x plus sin x in numerator, and we have cos x minus sin x In denominator, divide everything by cos x. You'll have 1 plus tan x, 1 minus tan x. This is the formula. Tan of pi by 4 minus x. What do we have outside? Please check. Tan inverse of this bracket becomes this. Tan of pi by 4 minus x. So I am showing you how to do it, but if you remember, the form will be easier. Okay, so please remember this form. This and this, remember the form. If it is minus and plus, this becomes pi by 4 plus. Excuse me. Yeah, my bad, this is plus, right? Plus. Sorry, yeah, plus. So over here, not minus. If this is minus and this is plus, okay, yeah, correct. This becomes minus sign. This is minus and this becomes minus. That's the form. So y equal to what I'm getting here? Pi by 4 plus x. Differentiate now. This is easier. 0 plus 1. Answer is 1. That is option number D. That is option number D. Clear or not? Yeah. Okay. Question number 13 now. Look at this. Please don't get lost in solving that question for first part. X power x is a logarithmic differentiation. It will take time. So it is easy, I know. It will take 30 seconds, 40 seconds. Still it will take time. Look at the options. Each of the option has same first part. It means derivative of x power x is already given to you. Then why are you finding it? Why are you finding this if it is already given to you? So don't look at this, just look at this. Derivative of this will be what? A x power a minus 1. So this will be what? A power x log a. This will be what? Constant, so 0. So look at that. A x power a minus 1, a power x log a. 2 seconds to 3 seconds. Formula based question. Mistake that we will make in this problem is start differentiating from the first part. Always check out the option. Option can help you solve the question faster. Yes. Question number 14. Question number 14. A very, very good question. Before we proceed, draw the graph of cos and sine. Sine function is this, sir. Cos function is this, sir. Cos function is this. This where they meet is nothing but pi by 4. 1 by root 2, 1 by root 2 the value for sine and cos both. Let me show you. This is sin x and this is nothing but cos x. So pi by 6 is over here before pi by 4. Pi by 4 is 45, pi by 6 is 30. So before pi by 4. Look carefully. At pi by 6, cos x is more than sin x because graph of cos x is higher. Check, cos x is higher. So cos x minus sin x is more than 0. If I move sin x over here, means cos x minus sin x is positive. It is positive. So this modulus I can open now directly as cos x minus sin x. I don't need modulus anymore because this is a positive value. Otherwise I'll need to apply a minus sign if it was negative. Differentiate, please. Cos is minus sin x and sin is cos x. Take minus common, we are getting sin x plus cos x. Sin 30, 1 by 2, cos 30. Pi by 6 is what? 30 only. Sin 30, 1 by 2, cos 30, root 3 by 2. Add them. Please cross check. Solve it and check. Put the x value as pi by 6. You will get the answer as option A. Question number 15. This is also the PYQ from this year. This year's PYQ. Okay. Y equal to root of tan x plus y. Remember this form. Y equal to root of tan x. What is y? Same thing. Tan x plus. Again we'll have y. So remove y. You will have same thing. Tan x plus y. Again remove y. You will have same thing. Again remove y. You will have same thing. So basically you are having this special series of sum of this root of the function f till infinite number of terms. Derivative is there, right? There is a straightforward formula. dy by dx is equals to derivative of tan upon 2y minus 1. Derivative of tan is what? Secant square x upon 2y minus 1. How do we get this result? From log differentiation only. But remember this formula. What formula is this? If you have y equal to root of f plus root of f plus root of f like this, then y dash is given by f dash upon 2y minus 1. Answer is, they have given the same option. Sorry, I'll take one of them out. They are the same option actually. My mistake. My bad. They're the same option. Should have changed it. Okay? But yeah, option A or B, same thing. Clear? Okay? Let's see one more from this here. This question number 16. Second order derivative of sec inverse. Look at this carefully. This is cos inverse of, let's say this is A. What is this going to be? Sec inverse of 1 by A. This becomes what? If you write, it becomes cos inverse of A. So they are asking us to differentiate cos inverse of A by, differentiate cos inverse of A by cos inverse of A. Differentiate this. What is the answer going to be? 1. Answer will be 1. If you're not sure, differentiation of x with x is how much, guys? Is 1. Differentiation of t with t is how much, guys? 1. So the same function, if you differentiate with itself, derivative is 1. What are they asking us? Second derivative. So this is the value of first derivative. y1 is coming as 1. Derivative of y1 will be how much? If it is constant, 0. If the first derivative is constant, second derivative is 0. Please check. Yes. So this is the end of your lecture. Okay, where I completed all the theory. I've done 15 plus boards MCQs, board style subjective questions, PYQs, KCET MCQs, all was discussed, right, in this class. Let me know how was the session. Let me know what can be done to improve it, what should be done better. All of it you should let me know in the comment section. And you have the access to AIO platform, all-in-one learning platform. It's right here. Okay, start using it right now. Click on this link, free ACE KCET course. Click on that link, log in, start learning from the platform. You'll have all of it. You'll have all the notes, all the question assignments, PYQs. Sorry, if this is PYQ session, you get PYQ also. You get doubt solving also. See, if I want to check the class note, this is the class notes. So everything is available in the platform itself. Start using it, start learning from here. Okay, it will certainly benefit you, and this is all for free. There's no charge behind it. So it doesn't mean that you don't have to take it seriously. Just because it is free doesn't mean you can just take it simply lightly. We are providing you free opportunity to learn in an online learning, a classroom experience. So take it seriously. Start learning today. That's all in this class. I'll see you in the next one. Till then, take care. Bye-bye. All the best.